Good morning. Our distinguished chief guest and keynote speaker, Dr. Sudhir Arbusar, scientist, Cement, Pune. Our eminent resource person, Professor Akio Kimura, Graduate School of Science, Hiroshima University, Japan. Honorable President of Janta Shikshan Sanstha WAI, Sri Madan Dada Bhosle. Respected Secretary Chaudhary Sir, respected Treasurer Narayan Chaudhary Sir, respected Directors of Janta Shikshan Sanstha, President of the Inaugural Function, respected Principal Dr. Gurunath Phagre Sir, respected Vice Principal Professor Dr. Vinod Bir Sir, respected Professor Dr. KVM Rajpure Sir, Professor and Scientist Department of Physics, Shivaji University, Kolhapur. Dr. S.H. Mujawar, Research Director, KBP University, Satara. Co-convener, Dr. Sandeep Wategaonkar Sir. IC-IASET Coordinator, Shivaji Kamble. Distinguished delegate, respected researcher, faculty members, students and dear participants from India and abroad. A very good morning to one and all. It gives me immense pleasure and deep sense of honor to warmly welcome you all to the one-day international conference on interdisciplinary approaches in science, engineering and technology. This international conference is jointly organized by the Faculty of Science, Research and Development Cell, IC-IASET of our institute, in collaboration with the Aerogel Material Research Center, Yonsei University, South Korea, which is ranked 73rd in the world QS ranking under an MOU. This collaboration reflects our institution have a strong commitment to global academic partnership, cutting-edge research and interdisciplinary innovation. The main objectives of this conference is to bring academicians, scientists, researchers and students to deliberate an emerging trend and recent advances in the sciences, advanced material, industry 4.0 and smart manufacturing, sustainable energy, environment, green technologies, engineering and technology. In today's rapid evolving world, the boundaries between the science, engineering and technology are increasingly overlapping. Interdisciplinary research plays a crucial role in addressing complex scientific and technological challenges. And this conference provides an excellent platform for knowledge sharing, collaboration and innovation. We are indeed privileged to have with us today Dr. Sudhir Arbusar, scientist from Cement, Pune, as our chief guest and keynote speaker. His outstanding contribution to material science and advanced research continue to inspire young researchers and academicians across the nation. We are equally honored to welcome Professor Akio Kimura from Hiroshima University, Japan. His presence adds immense academic values and global perspective to this conference. His expertise and international research experience will undoubtedly enrich our understanding interdisciplinary scientific advancement. On behalf of the organizing committee, I extend a warm welcome and heartfelt welcome to all the speakers, delegates, researchers, faculty members and students. I am confident that today's deliberation will lead to meaningful discussion, innovation, research direction, and long-lasting academic collaboration. Once again, I welcome you all and wish the conference very success. Thank you.
Thank you so much, sir, for your earnest welcome and brief introduction of the conference. It's our culture to welcome and honor our dignitaries. May I now request Honorable Madan Dada Bhosle, the President of Janta Shikshan Sanstha, to welcome and honor today's keynote speaker, Honorable Dr. Sudhir Arbusar, Scientist, Cement, Pune. I request Honorable Dada, the President of Janta Shikshan Sanstha WAI, to honor our today's keynote speaker, Honorable Dr. Sudhir Arbuz, the scientist, CMET Pune, by offering shawl, bouquet and memento. Honorable Dada is honoring our today's keynote speaker, Dr. Sudhir Arbuz. Thank you so much, sir, for accepting our honor. I would like to request our principal to welcome and honor our today's chief guest, Honorable Shri Madan Dada Bhosle, President of our Janta Shikshan Sanstha, by offering bouquet. So, respected Dr. Gurunath Phagre sir, the principal of our college, honoring our president. Thank you, sir. I would like to request Professor D.N. Zamre sir, the convener of this today's international conference, to honor our respected principal and president of this inaugural ceremony, Dr. Gurunath Phagre sir. Thank you, sir. I request Honorable Dada to honor today's convener, Dr. D.N. Zamre sir, the convener and head of the chemistry department. Thank you, sir. I request Dr. D.N. Zamre sir to welcome co-convener of this program, Dr. S.B. Vategaonkar sir. Thank you so much, sir. Okay. Now, may I now invite Dr. S.B. Vategaonkar sir to introduce our today's chief guest.
Hello. It's my great pleasure to introduce today's chief guest, respected Madan Dada Bhosle. The esteemed president of the Janta Shikshan Sanstha, WAI, is widely admired for his dynamic leadership, visionary thinking and solid dedication to public service. Serves as a member of Legislative Assembly representing the WAI, Khandala and Mahabaleshwar constituency. He has consistently worked with the exceptional commitment to the welfare and development of the society. His sincere efforts in strengthening educational infrastructure are truly commendable. The work he has carried out in front of colleges, college library and classroom, along with the construction of the well-planned footpath from the Y bus stand to the college entrance, reflects his thoughtful approach towards the providing a safe, accessible and progressive academic environment for students and faculty. In the cooperative sector, Dada has demonstrated outstanding administrative skills and remarkable foresight. His 18 years of dedicated service as a chairman of the Kisanveer Satara Cooperative Sugar Factory Bhuins stands as a shining example of his strong leadership and deep understanding of the cooperative development. He also strengthened the Khandala and Pratapgarh cooperative sugar factories. His valuable contribution as a governing council member of the Vasant Sugar Institute further highlights his commitment to advancing agriculture and industrial growth. At Kisanveer Satara Cooperative Sugar Factory Bhuins, under his inspirational guidance, several innovative and farmer-friendly projects such as mineral water project, hydroponic fodder project, organic fertilizer project, ethanol project, and bioculture laboratory have been successfully implemented. The establishment of 22 megawatt bagasse-based cogeneration unit and CNG project in collaboration with the Germany company reflect his progressive vision towards sustainable and eco-friendly industrial practices. His initiative like Marta's Memorial Android application for sugarcane harvesting and agriculture and flower exhibition showcase his deep respect for farmers, technology and cultural values. His remarkable social commitment is further evident through his initiation of the prestigious Abasai Veer Social Award, which honors to those who tirelessly serve society. His strong belief in environmental conservation is demonstrated through the large-scale tree plantation drives, including the development of the Nakshatra Garden and Plantation Initiative at Kaneri Mutt. These green efforts reflect his noble vision of preserving nature for future generation. Madan Dada Bhosle's dedication to social welfare extend to impactful grassroots initiatives such as providing Pockline machinery for water conservation projects, supporting fire bridges services. His compassionate and people-centric leadership has significantly improved the quality of the life for the many communities. His concern for employees is equally admirable and reflected in organizing sport activities, spiritual recitation and collective reflection programs, and arranging interaction with the knowledgeable experts from the India and abroad, which contributes to the personal and professional enrichment. His invaluable contribution to the field of education is excellent. As a president of the Janta Shikshan Sanstha WAI and Mahalakshmi Shikshan Sanstha Bhuins, he has continuously worked towards enhancing academic quality and institutional growth. The remarkable improvement carried out in the college, including garden development, extensive tree plantation, campus beautification, and the establishment of the modern lecture recording studio, demonstrate his progressive outlook and commitment to the providing world-class educational facilities. His progressive outlook towards the youth empowerment is evident through the establishment of Skill Development Center, which provides valuable training opportunities, enhances employability, and equips young individuals with modern technical and vocational skills required in the today's competitive world. His deep commitment to gender equality and social progress is admirably reflected through the establishment of Women Empowerment Center. This noble initiative has created meaningful opportunity for women to develop skills, gain financial independence, and build confidence, thereby strengthening their role in society and contributing to overall community development. Through his inspiring leadership, tireless dedication, and compassionate service, Madan Dada Bhosle continues to be a guiding force, earning immense respect and admiration from all sections of society. Thank you.
Thank you so much, sir, for such a giving nice introduction of our chief guest. May I now invite Dr. S.H. Mujawar, Research Director, KBP University, to introduce today's keynote speaker, Honorable Dr. Sudhir Arbuz.
Good morning all. It's really a great pleasure for me to be here on the occasion of inaugural function of this one-day international conference on interdisciplinary approaches in science, engineering, technology. Friends, I am always happy to be here with you all because I am a student of this particular institution. I graduated from this college in 2000, and again I am here to introduce my close friend Dr. Sudhir Arbuz. First of all, I congratulate the organizer of this particular institute for organizing this kind of event for the young students, because I hope that these kinds of events help students to shape their career and to promote them for higher education and research. So today we are having Dr. Sudhir Arbuz sir as a speaker for this particular keynote speaker for this particular conference. Dr. Sudhir Arbuz is working as a scientist at Center of Materials for Electronic Technology, CIMET Pune, since 2008. He completed his master's from Nauroji Wadia College, Savitribai Phule University, Pune. Dr. Sudhir completed his PhD in photocatalysis from Department of Chemistry, Savitribai Phule University, Pune. He also worked in reputed institutions like National Chemical Laboratory, Pune, and Bhabha Atomic Research Center, Mumbai. Dr. Sudhir is working on different nanomaterial synthesis, photocatalytic properties, hybrid solar cells, hydrogen storage devices, as well as he is having a huge experience in fabrication of different types of lithium-ion batteries, sodium-ion batteries, and zinc-ion batteries. He is working on materials for additive manufacturing, etc. So Dr. Sudhir is having a huge experience in research, and he has published almost 102 research papers in different international journals. He has attended several national and international conferences in India and abroad. He served as guest editor for several reputed publishers like American Scientific Publishers, Elsewhere Publishers, and Royal Society of Chemistry Publishers. Dr. Sudhir is also a fellow of Maharashtra Academy of Sciences. He has guided more than 6 students for pursuing their PhD, and Dr. Sudhir has guided more than 76 students for their master's thesis. So apart from his huge academic and research contribution, I would like to mention here that Dr. Sudhir is not only a good academician and researcher, but he is a good human being, because he is my close friend, and from last 5 years, more than 10 students are working under his guidance for pursuing research experience at international level. So I welcome Dr. Sudhir for this particular conference, and I congratulate organizers for organizing this particular event. Thank you very much, sir.
Thank you very much, sir. We are very proud. Our ex-student is on the dais to introduce our keynote speaker of the international conference. Thank you so much, sir. The person who is a great source of inspiration and visionary, who is none other than our respected Honorable Madan Dada Bhosle. I take the privilege to invite him for the inaugural address.
Namaskar, Namaste, and good morning to you all. Today's keynote speaker, Dr. Sudhir Arbuj, scientist from CMET, Professor Akio Kumura, Professor, Graduate School of Science, Hiroshima University, Japan, scientist and Professor, Shivaji University, Dr. KVM Rajpure, Research Director of KBP University, Satara, Dr. S.H. Mujawar, Principal, Dr. Gurunath Fagre, Vice Principal, Dr. Vinod Veer, Conveyor of this conference, Professor D.N. Zamre, Co-Conveyor, Dr. Sandeep Wategaonkar, resource persons, researchers, teaching and non-teaching staff, and students. I extend my very warm welcome to you all in this one-day international conference on interdisciplinary approaches in science, engineering, and technology, jointly organized by Faculty of Science, Research and Development Cell, and IC-IASET of our college in collaboration with Aerogel Materials Research Center, Yonsei University, South Korea, under the Memorandum of Understanding formally signed in the recent past. Our collaboration with Aerogel Materials Research Center has created valuable opportunities for research exchange, knowledge sharing, and global exposure for our faculty and students. As a president of Janta Shikshan Sanstha, I feel extremely pleased that this year, this international conference is being organized as a part of the MOU. All of us know well the advancement of science and technology depends largely on interdisciplinary collaboration. Such challenges before humanity as sustainable energy, advanced materials, climate change, healthcare innovations, or digital technologies cannot be addressed by a single discipline alone, hence the need of organizing a conference on interdisciplinary approaches integrating science, engineering, and technology. I congratulate Professor H.H. Park, Director, Aerogel Materials Research Center, Yonsei University, South Korea, and the members of the Faculty of Science, R&D Cell, and IC-IASET of Kishanvir Mahavidyalaya for their dedicated efforts in organizing this international event. Dear students and researchers, I encourage you to make the most of this opportunity and participate actively in discussions, present your ideas with confidence, and build meaningful academic connections both offline and online. At Janta Shikshan Sanstha, our mission has always been to promote quality education, research culture, and holistic development. We believe that institutions must prepare students not only for careers but also for leadership in knowledge creation. This conference reflects our dedication to nurturing such an academic environment. With immense pleasure and pride, I now formally declare that this one-day international conference is inaugurated. I wish the conference great success and hope that today's deliberations will lead to impactful research outcomes and long-lasting academic collaborations. Thank you, one and all.
Thank you so much, Dada. Certainly, your address goes a long way in inspiring us to strive hard and achieve more. I would like to request respected Principal Sir to honor and welcome our Secretary, Honorable Dr. Jayant Chaudhary Sir, the Secretary of Janta Shikshan Sanstha, who has joined us now for the inaugural ceremony of International Conference. So, thank you, sir. So, I take the opportunity to invite respected Principal Dr. Gurunath Fagre to deliver a presidential address.
Good morning, all. I would like to welcome you all for this international conference on interdisciplinary approaches in science, engineering, and technology. Honorable President of our Janata Shikshan Sanstha, Madan Dada Bhosle, Honorable Sachiv, Secretary of Janata Shikshan Sanstha, Dr. Jayant Chaudhary, Keynote Speaker, Dr. Arbut Sir, Convener of this organization, Professor Dr. Zambre Sir, Professor Vategaonkar Sir, Vice Principal Dr. Veer Sir, my friend Dr. Rajpure Sir, Mujawar Sir, all the teachers, faculties, students, researchers, and friends. This conference has opened the way to think on different areas, different aspects, different questions, and to answer the different issues that may arise and have arisen in the life. And there is always a question in my mind, why this science is, why this engineering is, why this technology is. To my mind, the answer is to make the life simple, easy, and happy. And from this point of view, we have gathered together to answer the issues that may create or that have created in our lives. I will take few examples. We are experiencing today the traffic congestion everywhere. From that point of view, if we will be able to answer this question by devising a car that can fly in the air for a short distance to overcome the traffic congestion, and again that car can go away by road. Another example I would like to quote, an aeroplane that may stop in the air for waiting the passengers who are waiting on the road. The ladder will come down. He will be scanned on that ladder. He will be taken in the airport, in the Airbus, and his journey will be continued. Are we able to answer such kind of answers? Or are we able to come out with such solutions? Another example I would like to quote, पंछी होती तो उड़ा आती रे मेरे दिल का दाग दिखलाती रे. हे कवीनं मांडलेलं एका प्रेमिकाचं उदाहरण सांगितलेलं आहे. Are we able to, or can we devise such kind of wings to a man so that that man can fly to the desired destination and show the mindful dogs? And are we able to devise such instruments that device can show the heart dog. जे आपल्या हृदयावरती जो डाग आलेला आहे तो आपल्याला पाहण्याची दृष्टी निर्माण करण्याची काही इन्स्ट्रुमेंट्स आपल्याला सायन्समधून घेता येतील का? अशा पद्धतीचे विविधांगी अशा प्रकारे निर्माण होणारे लाईफ क्वेश्चन्स जे आहेत, जीवनामध्ये येणाऱ्या ज्या वेगवेगळ्या समस्या आहेत, या समस्यांवरती उत्तर शोधण्यासाठी वी हॅव केम टुगेदर फ्रॉम डिफरंट फॅकल्टीज, फ्रॉम डिफरंट एरियाज and from different specializations. So, we are gathered here together to answer such kind of live questions and come out with the solutions so that we can have a discussions, discourse and the decisions so that we can give answer to such large questions. One more example I would like to put here, that the water bottles we are using everywhere, and those water bottles are creating environment problems. Are we able to give solution to these bottles? Instead of plastic bottles, can we devise such bottles from the what we call the starch? मक्यापासून जे स्टार्च तयार होतं किंवा ऊसापासून जे काही साल निर्माण होतं त्याच्यापासून अशा प्रकारचे काही बॉटल्स आपल्याला तयार करता येतील का, की जेणेकरून आपल्याला एन्व्हायरमेंटवरती देखील उत्तम उत्तर शोधून काढता येईल. सो once again I am very happy to welcome you all to discuss all these kind of questions, to discuss on your ideas, views, research and expertise, and to come out with the solutions to all such kind of questions or the issues. Thank you.
Thank you very much, sir. Your wishes and thought-provoking address in English set a perfect platform for our researcher. May I now invite Dr. S.R. Tate, sir, to propose a vote of thanks of this inaugural ceremony. Dr. S.R. Tate, Associate Professor and Head of the Mathematics Department.
Honorable Chairperson, distinguished Chief Guest, respected dignitaries on and off the dais, colleagues, and dear participants, good morning everyone. First of all, it is my proud privilege to express deep sense of gratitude to Chief Guest of the inaugural function, Honorable Shree Madan Dada Bhosle, President Janata Shikshan Sanstha WAI, for gracing this function with his inspiring presence and for delivering the inaugural address. We are immensely grateful to esteemed scholar Dr. Sudhir Arboj, scientist, CMAT, Pune, for his gracious presence at this occasion. I extend my sincere gratitude to Dr. Jaywan Chaudhary, Secretary of Janata Shikshan Sanstha, for their gracious presence and constant encouragement. We are grateful to our collaborator, Professor H. Park, Yonsei University, South Korea, and Professor Vinayak Parale, Hiroshima University, Japan, for their valuable contribution in this conference. I sincere appreciation goes to Professor Dr. D.N. Zamre, Convener and HOD Chemistry, for the cordial welcome and introduction and for his dedicated efforts in organizing this program. I also extend heartfelt thanks to Dr. S.B. Wategaonkar for warm and thoughtful introduction of our chief guest, setting as the inspiring deliberations. And also I thanks to Dr. Mujawar sir for introducing our esteemed scholar, Dr. Sudhir Arboj. I would also like to thank Dr. Gurunath Fagre sir, Principal of Kishanvir Mahavidyalaya WAI, for his scholarly presidential address and constant encouragement and administrative support in making this event a success. Finally, I thank all the delegates and participants for their enthusiastic presence and active engagement. With this word, I once again express our heartfelt gratitude to all dignitaries and participants for making this inaugural function a memorable and meaningful beginning. And with the permission of the chair, this inaugural function is concluded. Thank you.
Thank you very much, sir, for your brief vote of thanks. After the inaugural ceremony, we are now moving towards the session first. So I would like to request Dr. S.H. Mujawar sir to chair the session of this second session. To chair the session. May I now invite Dr. Tripti Shinde to welcome and introduce today's session of the keynote speaker, Dr. Tripti Shinde, Assistant Professor.
Good morning, respected dignitaries. Good morning, respected dignitaries, delegate, research and faculty member, and my dear students. It is my great honor and privilege to introduce the chairperson for this second session of the International Conference on Interdisciplinary Approaches in Science, Engineering and Technologies. Dr. Sarfaraz Mujawar sir, Dean and Associate Professor at Research and Development, Yashwantrao Institute of Science and Technology, Satara. Today we are fortunate to have with us a highly respected academician and dedicated researcher who has made a remarkable contribution to higher education and research innovation. He has actively worked to motivate younger researchers, strengthening the research ethics and create a culture of innovation which is essential in today's competitive environment. Dr. Mujawar sir is known for his academic excellence, quality of research. His research area is physics, nanotechnology and material science. Dr. Mujawar sir has authored 64 research papers and 5 books. He holds 1 USA patent and 8 Indian patent. 5 PhD students doing PhD under his guidance, and out of them 2 submitted his thesis. He is an academic leader who promotes honesty, depth of thought and teamwork. Today's technical session and discussion will surely benefit much more from his advice and view. We are all greatly honored and inspired by his participation in this international conference, particularly the faculty and research experts. On behalf of the organizing committee, it is my proud privilege to welcome Dr. Mujawar sir as the chairperson of this session. We are confident that under his chairmanship, the session will be insightful and engaging. Ladies and gentlemen, please join me to extend a warm welcome to our respected chairperson, Dr. Mujawar sir. May I now request to Dr. Mujawar sir to kindly take a charge of desk. Okay.
Thank you, ma'am. Such a thoughtful introduction. May I now request our respected principal, Dr. Gurunath Fagre sir, to welcome the chairperson of today's session, Dr. S.H. Mujawar. Dr. S.H. Mujawar, Research Director, KBP University, chairing the session. And our respected principal sir is honoring and welcoming our chairperson, Dr. S.H. Mujawar, by offering memento, bouquet and flower. Thank you so much, sir, for accepting our honor. It's my privilege to invite Dr. Sudhir Arbus sir to address our audience, the scientist, CMET Pune.
Namaskar and very good morning to all of you. So, respected Honorable Dada, respected Principal of this college, Vice Principal, and my friends Professor Zambre, Professor Mujawar, Professor Vategaonkar, other dignitaries, and my students. I am really honored to be here for giving a keynote lecture entitled Engineering of Semiconductor Nanostructures for Enhanced Photovoltaic Hydrogen Generation. So already Honorable Dada and principal of this college told you that interdisciplinary research is very important. And let me tell you that now this is the era where all the subject researchers has to come together, all the academician as well as engineer has to come in hand to develop certain kind of devices. Before, what is happening, physics, chemistry, biology people, they have their own kingdom and they are not allowing to interfere their own kingdom. But drawback of that is that one cannot able to make certain kind of devices. People understand that we have to do mutual research, then only we will get certain fruitful devices. For example, just let me tell you, glucometer. This is the most usable device today. Glucometer requires materials, physics and electronic people. And of course, without biology, we cannot identify the glucose in our blood. So just keep in mind the glucometer. This is for example only. If you want to develop certain kind of devices, you have to come together and do interdisciplinary research only. So let's begin with today's talk. So I am going to talk about the semiconductor nanostructure photocatalysis. So before going in today's detailed topic, let me introduce about my bread and butter, my institute. So I am working at Center for Material for Electronics Technology. It comes under the Ministry of Electronics Information Technology. So we have 3 labs, CMET Pune, its lab as well as headquarter, CMET Hyderabad and CMET Thrissur. All these labs have independent mandate in what area they have to work. So CMET Pune working in the area of nanomaterials, solar cells, lithium-ion batteries, additive manufacturing, and 2D materials for quantum computing applications. So this is the mandate of our CMET Pune. CMET Hyderabad people are working in the area of high purity material that are being used in the electronic sector. High purity means up to 13 N purity or 15 N purity. Means if you say 99.9, so that is 3 N purity. Like that, our CMET Hyderabad team, they are developing the materials that are up to 13 N or 15 N purity materials. And CMET Thrissur, they are working dedicatively on microwave absorbing antennas. Now, one more artificial organ with us, mobile. That is our one more additional artificial organ. Without mobile, we can't live now. So that mobile containing certain kind of antennas. So that kind of antennas is being developed by CMET Thrissur scientists. So this is one example, but whatever the antennas required in the satellites or in navigation that are being used or developed by CMET Thrissur. So can I have the control of slide, please? Okay, do it. Okay. So, okay, why I choose this topic? Because now when I was studying in the school, our teacher used to tell that these fossil fuels one day getting vanish. So I used to afraid at that time. When we are going younger and we don't have the fuel, then how we can live? But see, this is the world, it is going smoothly. Whatever the problems we are facing, scientists are developing solutions 20 years before that we are facing. So see, now everybody is searching for, next slide please. Everybody is searching alternative energy sources. Already Dada said that they are developing some CNG, bio-CNGs, that is okay, good. But now scientific community is trying to develop one universal solution, one universal fuel, that is hydrogen. Why people are developing hydrogen, why people are running beyond hydrogen is because if you burn 1 kg of gasoline, you will get certain 40 megajoules of energy. But if you burn 1 kg of hydrogen, you will get almost 3 times of more energy. Almost 120 megajoules of energy is being getting from the burning hydrogen. And side product is water only, H2O. See, there is no pollution. That's why in the whole universe, people are running behind the hydrogen. But now, how to produce this hydrogen? Conventionally, hydrogen is being produced using steam reforming method. Now, I think in 9th standard or 10th standard, this process is already mentioned in the science subject. How to prepare hydrogen using steam reforming. This is the most favorable method industry is trying, and almost 95% of the requirement of hydrogen is produced using this steam reforming method. Another one is coal gasification and whatever this water electrolysis. Only remaining 5 to 10% hydrogen is being produced using this water electrolysis process. Means we have very much problematic processes these are. Because why this is problematic? Steam reforming, it requires high temperature and high pressure. And what is happening due to this? The cost of hydrogen is higher. That's why we unable to use hydrogen as a fuel at a present level, because gasoline is much cheaper than the hydrogen that we are producing with this method. So now people are trying to develop eco-friendly and much cheaper hydrogen development method. See here, depending upon the process and depending upon the side products, whatever you are getting for the hydrogen generation, the process is defined, or hydrogen is given this much colors. I also don't know hydrogen exists in these colors. Hydrogen is colorless, but based upon the process, it is termed as a hydrogen. Now you must have seen in the many newspapers or TV that green hydrogen. Green hydrogen. So that is our role. So what is mean by green hydrogen? Green hydrogen means using sunlight, you can produce hydrogen without emission of carbon dioxide or carbon monoxide or all side products. That is called green hydrogen. So people are using solar cells. With the help of solar cell and electrolyzer, they are splitting water and they are getting hydrogen and oxygen. So that is total green, whatever we are calling this as a green hydrogen. And in 2023, our Prime Minister Modi ji started the hydrogen mission. And in that hydrogen mission, the main target of this mission is to sustain or become global leader in the hydrogen, green hydrogen production by India. So based upon this process, see here, brown-black hydrogen means if you use coal and steam reforming method, you will get hydrogen and CO2 is released in the environment. CO2 is released, another greenhouse effect. So it is called brown-black method. This white is naturally occurring hydrogen. Naturally occurring hydrogen is only ppm level that we cannot use for our day-to-day need. Gray hydrogen, if you absorb this release CO2 by certain means, then it will be gray or blue color. So these are the various colors based upon the hydrogen preparation method. So we are going to talk about the green hydrogen production, which produce only hydrogen and oxygen. See, these are the various applications of hydrogen. Without hydrogen, our chemical industry will not work. Even I came to know that here MSc organic chemistry students, if you want to prepare some organic molecule, you require hydrogen for reduction reaction. So these are the various applications: fuel production, then industry feedstock, and for the energy crisis. Now you know that on fuel cell based upon hydrogen, the cars are coming in the market. But what is happening? There is, as the time goes, the research area also goes or changes, and we have to change accordingly. When I was doing master or sir is doing their graduation, at that time people are working on the geolites. So geolites came, everybody is working on geolite, and that geolite used to crack this gasoline so that the fuel production rate enhances and we are getting much more pure hydrogen, hydrocarbon fuel. Then what came? Nanomaterial came in 2000. So after 2000 nanomaterial came, then people are working on the photocatalysis. After that, people are working on solar cells. And now recently, people are working on lithium-ion batteries. Everybody is working on lithium-ion batteries. Before 1990, people are working on fuel cell. But the production for hydrogen is get hampered. So that research came back, working on fuel cells. So now we are facing much problem for getting the lithium metal. So though we are making, or we are much enough expertise we have to fabricate the lithium ion batteries, but the raw material for lithium we are lacking, and that basically we have to import from China. To avoid the uses of lithium ion battery, now government of India again started or given funding in the area of green hydrogen production. So we are again getting some funds from government of India to do this kind of research, and that will be beneficial. If it works, then I assure you that this your whatever your generation will be the most comfortable living generation on this planet. So here I am using photocatalysis technique to produce hydrogen. So in that case, what is the basic funda is that we have to use sunlight, we have to develop the catalyst, and using water, with the help of sunlight, we can split the water in the hydrogen and oxygen. So in short, this is called catalytic reaction involving light absorption by catalyst. In other words, we can say photocatalyst on semiconductor is a redox reaction. Photocatalyst is the acceleration of photoreaction in presence of light. Means certain kind of reactions are already there, but using catalyst, we can accelerate the rate of that reaction. Very first report came in 1972 by these two scientists, Fujishima and Honda. They are performing certain kind of experiments. They developed some photoanode of TiO2. And after shining light on this TiO2, they observed that evolution of certain kind of gas at platinum electrode. They analyzed that and they came to know that the whatever gas liberated at platinum is hydrogen gas and at anode is oxygen gas. At that time, this is the new phenomenon. New phenomenon occurred in the scientific community. Everybody is thinking that we can effectively use solar light to split the water and generate hydrogen. So this is the basic mechanism. Okay, what we required semiconductor material for this. Semiconductor means, if you know, metal, semiconductor, insulator. Based upon the band gap, material is divided in three types. Okay, metal means metal don't have band gap. The conduction and valence band is almost overlap. Second, semiconductor. This gap is up to 3 electron volt. And above 3 electron volt, if this valence and conduction band is having 3.5 electron volt, 3 electron volt, that is called insulator. Okay, this is the basic difference between metal, semiconductor and insulator. So we are developing semiconductor material. This semiconductor is having valence band and conduction band. If you shine this light on this semiconductor material, this electron from valence band goes to the conduction band and it creates electron hole pairs. This electron react with the H plus molecule from water and it generates hydrogen gas. At the same time, the holes present in the valence band react with the oxygen and it forms the oxygen molecule. Water, it oxidizes to oxygen molecule. In this way, one can able to split water using sunlight in the hydrogen and oxygen. So this is the most cheapest method to produce hydrogen using sunlight, natural ecosystem, and this will be a green hydrogen production. So after developing this method, people have found another applications also for this photocatalyst technique. So this is for water treatment, self-cleaning effect, air cleaning effect, for organic reactions, for hydrogen generation, antimicrobial effect, anti-fogging effect, volatile organic degradation. So this technology or this phenomenon is utilized by all types of researchers. Biologists use for anti-fogging or antimicrobial effect. Physics people are using, chemistry people are using. All types of researchers are using this kind of phenomenon. So, but every material to produce hydrogen, they have certain classification or certain criteria. Because without fixing some criteria, we cannot get the perfect utilization of that catalyst. So what is this basic criteria? Is absorption of light of particular wavelength. See, solar light is having broad emission spectra. It's ranging from 200 to 1500 nanometer. So UV light range is 200 to 400 nanometer. It is only 4 to 5% in the solar spectrum. Whatever visible light, that is 35% visible light available in the sunlight, 400 to 800 nanometer, and above 800 nanometer, that is IR region, that is almost 45% IR region. So basically we have to develop the catalyst in such a way that can utilize your visible portion of the solar light. Another criteria is that generation and separation of photo-generated charge carriers. After striking the light, electron hole pair are generated. But before redox, they are providing reduction to the water, they are again combining. So that photon will be useless for us. Nature of semiconductor and band positions. This is the basic criteria. Whatever the conduction band level, it should be more negative than the valence conduction band more be negative than the hydrogen evolution potential. Only that material will produce hydrogen using this phenomenon. Then nature of metal loaded semiconductors, method and extent of metal loading, doped semiconductor and coupled catalytic system. These are certain phenomena that can be utilized to enhance the photovoltaic activity of some materials. So other uses of this semiconductor oxide and sulfides are photovoltaics. Means if you develop certain kind of metal oxide sulfide, you can use that material for other type of devices or other phenomena. See here, this photovoltaic solar cell, battery electrode, lithium or sodium ion battery, gas sensing, all metal oxides are used as a gas sensors. For organic transformation, such as selective oxidation, acid-base catalysis as support, you know that carbon-carbon coupling Hake reaction required palladium catalyst on TiO2 support. Then the nanoelectronics and optoelectronics applications, such as flexible electronics, transparent electronics. The mobile screen you are having, that is indium tin oxide, transparent electrolyte. Spintronics and catalysis, that is magnetic oxide material used for data storage, then electrocatalysis for hydrogen evolution reaction, and this is for photocatalysis for water splitting and photodegradation. So this kind of particular reactions we are going to see here. So now come to our materials. So at CMET, what we are doing, we are developing different kind of nanomaterials, and we are characterizing that nanomaterials for our particularly photovoltaic hydrogen generation application. So let me tell you students, those who are good in kitchen are good in material synthesis. And material synthesis is the collaboration of physics as well as chemistry people as well as electronics people. Means physics people cannot say this is my area, physics, chemistry people cannot say my area, biology people also cannot say, because this is material, this is interdisciplinary material. Anyone can prepare these nanomaterials. Many papers I have seen that biology people are using some plant extract and they are developing nanomaterials. Physics people are developing different methodologies to develop certain kind of nanomaterials. Chemistry people using their chemistry knowledge, using certain capping agents, they are developing beautiful materials. So that's why I am telling you, you know that various tea wala, chai wala available with us. And if you taste the tea, each taste have different flavor. So that is Yeule chai, Saiba chai, many chai wala there. You know that what they are doing, they are changing their additives. If you change additives, you will get different flavor, get different taste. This is the role of chemistry or physics people. They are putting some capping agent in the catalyst. Due to that, your catalyst will grow in particular direction or create certain kind of defect or create mesoporous structure, and that property we can use for our particular application. So that's why from this slide I am going to show you different kind of nanomaterials and what are the properties of that nanomaterials and how we tune its properties to achieve higher photovoltaic hydrogen generation. So here what we did, we prepared this TiO2, titanium dioxide, simple, using sol gel technique. And what we did, we heated this material for 400 to 800 degrees centigrade just to see what is happening, what is the physical phenomenon or what is the structure activity relationship. So what we did, we heated 400, 500, 600, 800 degrees centigrade. We check its XRD, hope that you know XRD phenomenon. So XRD gives us what is the phase of material and what is the particle size. So we observed that as we heat this material from 400 to 900, 800 degrees centigrade, the anatase phase starts converting from anatase to rutile phase. See here, this is the peak due to anatase and this is due to rutile. At this 600 degrees centigrade, this anatase phase starts converting into rutile phase. At higher temperature, a whole complete vanish, this anatase phase is vanished and complete rutile phase form. And in TiO2, it is well studied that anatase phase is having highest photovoltaic activity. So here we came to know that we cannot heat our material beyond 600 degrees centigrade, otherwise it will change its crystal structure from anatase to rutile. So this particular phenomenon we came to from this structure. So this is the TM micrographs. See, this is the band gap of the material, what I told you, distance between the top of the valence band to the bottom of conduction band. And here we tested its photovoltaic activity. So here what we observed that the TiO2 prepared at 400 degrees centigrade giving highest hydrogen generation as compared to other prepared TiO2 material. Almost 1200 micromoles of hydrogen is being produced by using 0.1 gram catalyst. So here what I came to know that anatase phase at lower temperature is having highest photovoltaic activity. So this is the photovoltaic reaction setup here. Though I am saying here this is the green hydrogen production, but at my laboratory I have developed this schematic photoreactor and I am using 230 volt for starting the lamp, because what is happening, daily I cannot go on the terrace and do reaction under sunlight, because what is happening, in winter we have 10 degrees centigrade, in summer we have 40 or 50 degrees centigrade. If I want to compare my data of the material from winter to summer, it is giving lot of difference, because as a chemistry people we know that if you rise the temperature of any reaction by 10 degree, your rate of reaction doubles. So to avoid this, we have developed this mercury vapor lamp fitted in quartz condenser, and this is the round bottom flask. Here we are putting our water plus catalyst, and this is the idiometer tube where we are collecting our hydrogen and oxygen with respect to the time. So another what we did, we have prepared this TiO2 nanocubides. So here what is happening, we have taken the TiO2 that are being already in the market, and what we did some chemical treatment on that, and we reduced its particle size to get enhanced hydrogen. So here what happened, we have taken this TiO2 and we apply some hydrothermal reaction technique. So here what happened, we changes the reaction time from 200 degrees centigrade and we varied the time from 12 hours to 48 hours, and we identify what kind of changes happen in this material. See here, this is the TiO2, whatever we have taken commercial. After chemical treatment, it forms nice 5 to 10 nanometer particles. And the advantage of these 5 to 10 nanometer particles is that the surface area drastically increases. And due to increase in surface area, these water molecules adsorb on the surface of this TiO2, and we are getting higher number of hydrogen molecules or water splitting reactions. So these are few results of this material. So another what we did, see, being a chemist, our aim is to develop new material with new morphology. So here we developed the technique to prepare quantum dots, 1-dimension nanomaterial, 2-dimension and 3-dimension nanomaterial. This is the classification of nanomaterials. Those having particle size less than 5 nanometer, that is called quantum dots. If your nanomaterial is having wire-like structure, 1 dimension, that is called 1-dimension nanomaterial. If you have 2-dimension, XY coordinate, like sheet-like structure or paper structure, that is called 2-dimension. And 3-dimension means cube structures. So this is the basic classification of nanomaterials. So we have developed the methodology that n number of any kind of metal or metal oxide, metal sulfide, we can develop in any dimension. So here what we did, we prepared TiO2 in quantum dot, 1-dimension, 2-dimension, 3-dimension. And the aim is which dimension is having highest photovoltaic activity, that we have to identify. So we prepared these nanomaterials in various dimensions. See, this is wire-like structure, this is 2-dimension and this is 3-dimension structures. See this nice wire-like structure, and this is the quantum dots. So quantum dots is size is below 5 nanometer. And after checking its photovoltaic activity, what we observed that the TiO2 having 1-dimension structure is having highest hydrogen generation activity. It is giving almost 7,000 micromoles of hydrogen per 0.1 gram catalyst. So why we studied this? Because we observed that if your nanomaterial is having 1-dimension structure, the electron gets path for its movement, and instead of recombining with hole, it is going further for giving reaction, and we are getting highest hydrogen capability. Another what we did, we prepared some tin sulfide nanomaterials. So that must be some visible light active catalyst. In order to use solar spectrum, we use this tin sulfide nanomaterial. So it is absorbing 400 to 800 nanometer. So we developed this SNS2, and we could get, this is the morphology. See, you know the benzene ring. So benzene-like structure it is giving tin sulfide nanomaterials. So see, this is the beauty of your synthesis technique. If you use solothermal, hydrothermal technique, you can able to prepare this kind of nano structures. And this kind of nano structures have different properties. The material is same, but if you change its morphology, you will get different properties. See here what we got. Whatever the tin sulfide we prepared at 24 hours at 200 degrees centigrade, it is giving almost 6,000 micromoles of hydrogen. This is under visible light. Another what we did, to enhance its further capability, we loaded some nickel. You know that, take your own example. Students alone don't want to go college, or he is not feeling happy to listen the lecture. But if his friend is sitting with him, he is easy, my friend is there, okay, we'll go for college, or we'll go for lecture, or we'll go from gym. So same phenomena is getting applied here. If you load some particular metal on the surface of another metal, mutually they are giving highest photovoltaic activity. So why this is giving? Because see, nickel is having highest electronegativity, highest electron affinity. As soon as electron hole pair generates, it easily captures that electron and further gives for hydrogen generation. See, using this ACM and TM analysis technique, we can see atom by atom, the molecule or morphology, microstructure can be analyzed using this. So this is the TM micrographs, this is HRTM micrographs, this is elemental mapping. So here what we observed that 2.5% loaded nickel is giving highest photovoltaic activity as compared to pure SNS2. This nickel is giving highest activity, almost doubles. So another phenomenon is coupled catalytic system. I told you just now that single student don't want to attend the lecture or go college. If somebody is there, they can attend the lecture or go to the college. Same phenomenon is happening in the material also. See, this coupled catalytic system means what is happening? Two different semiconductors with two different band gaps. We have to make it. And at the same time, what is happening here? Yes, sir. So see, these two different semiconductors and two different band gap. If you shine the light on it, what is happening? The electron from individual semiconductor goes into the conduction band. And at the same time, what is happening? One conduction band of electron recombine with the one hole of another semiconductor. Means 50% electron hole pair we are sacrificing. But at the same time, another 50% electron hole pairs are available for the hydrogen generation reaction. See here, this one hole and this electron we sacrifice, it combines, but at the same time, this electron and this hole is available for our water splitting reaction. So based on this phenomenon, what we did, we prepared coupled catalytic system based on cadmium sulfide and zinc oxide nanomaterials. So here what we did, this is the beautiful picture of zinc oxide nano, pencil-like structure. This can be visible using zinc oxide nanomaterial on zinc oxide nanomaterials. And we observed that as we increases the loading of cadmium sulfide from 0.1 mole% to 5 mole%, we are getting enhanced photovoltaic hydrogen generation. In this same direction, what we did, we prepared TiO2 SNS2 composite. So we came to know this phenomenon. So we tried various semiconductor nanomaterials. We form its heterostructure and utilize for our photovoltaic hydrogen generation. See, this is the cubic structure is due to the TiO2 and this hexagonal structure are due to the tin sulfide. The coupled catalytic system we developed, and we found that whatever this composition, almost 5 mole%, it is giving highest hydrogen generation. If you load certain things, it has certain concentration that will give you optimum result. If you load higher, then it will act as a capping agent. If you load it lower, it will not give you higher activity. So another what we did ternary system. Which means here you have one friend, we added one more friend to get more work. So here what we did, we prepared zinc oxide, zinc sulfide, and that too loaded on graphitic carbon nitride. So here we observed that as we loaded this material, we are getting enhanced photovoltaic hydrogen generation activity. So another we prepared NiO graphitic carbon nitride composites. So it is also giving highest photovoltaic activity for the 2.5 mole% nickel loaded graphitic carbon nitride. This is the another class of material, amexine. Magazine, it is being studied from last 5 years. See here, let me tell you one thing, that in which area I am working, I am start working that area getting Nobel Prize. So I am not getting in that area then already. In 2012, I used to work on Hake reaction. That Hake got the Nobel Prize. Later on, I started working on lithium-ion battery. The battery people get the Nobel Prize. So this is the happening. So those area I am choosing, in that area people are getting Nobel Prize. So now as I used to prepare metal organic framework for hydrogen storage, and this year he got that Nobel Prize. So again I have to change my area. But this phenomena, this Fukushima and Honda, they are still not get Nobel Prize. So hopes this and solar cell, these two people are not getting Nobel Prize in the material. So hopes we can work in that area, you will get that Nobel Prize. So for you also, if you come in the researcher, you work either this solar cell area or photocatalyst, you will get definitely Nobel Prize. Others already given. So this is the magazine. So this is also new class of material. These people may work, those who are working in this area, they may get the Nobel Prize, like MOF, metal organic framework. So Umar Yagi got the Nobel Prize. So in this area also, if you work and do some societal work, when you are getting Nobel Prize, if that phenomenon is useful for the mankind, then you are getting Nobel Prize. So if you easily prepare, so in this photocatalyst, what I used to see the dream, someone is throwing this TiO2 powder on the river, and as soon as the sun rises, this water goes into hydrogen and oxygen. So that kind of material you have to develop having highest phenomena. So this magazine class of material, so here what we did, we utilized this magazine for developing the semiconductor oxide test. The one of student, he is working on this magazine and he is heating this material at 350 degrees centigrade. And he used to come to me, sir, that material is vanishing. We are not getting any peak due to magazine. So I said, yeah, at least you take XRD and show me what is the material. So as soon as we saw this material, XRD, this magazine transformed into the anatase phase of TiO2. I said, this is TiO2 material. So this is the composite of amexin and TiO2. It should have certain kind of photovoltaic activity. So we check its photovoltaic activity and we observe that it is having certain kind of photovoltaic activity. So it acts as a metal magazine, though here that student shown some semiconductor behavior, but it is having metallic structures. Another, we prepared this graphitic carbon and magazine, because why we are working on this is the new material. People may get Nobel Prize in this area, so we should have certain papers in this area, and unfortunately we can get certain active materials. So we are using these nanostructures for hydrogen generation. So we prepared graphitic carbon nitride amexin in this area, and we tested successfully for hydrogen generation. Another, what we did, we prepared SNS2 and amexin composites. So we developed these materials and we successfully tested its photovoltaic hydrogen generation. See here, almost 1000 micromoles of hydrogen is getting generated using this material. Another, what we did, these quantum dots, they are not stable. As soon as you try to remove their capping agent, it again agglomerates and it is from bulk material. So it's like students, they are never sitting quiet. They are always doing some chatting, and so to make them silent, we have to do something. So here what we did, we added these quantum dots in the glass matrix. And we developed these quantum dots and restricted its size in the glass matrix. How we use this? What we did, this is the host glass. We added bismuth sulfide quantum dots. And if you heat this, the size of bismuth sulfide quantum dots rising. And you know quantum phenomenon, quantum confinement, if you heat material, your particle size increases. So this phenomenon easily observes here. And we could able to generate maximum hydrogen using this kind of materials. So these are the SEM-TM micrographs of these materials. These are another bismuth sulfide doped quantum dots. See here what we did, we coated our TiO2 material on this glass plate, and in beaker that is water, and we could able to see under sunlight small bubbles, that is due to hydrogen and oxygen. Can you click on this slide? Yeah, yes, it's rising. See here. This is the hypervences, same like here. So if you make it bigger, on bigger scale, you will get maximum number of hydrogen oxygens. Okay, now this is the conclusion. So the separation of photo-generated charge carriers decide the efficiency of catalytic system. Whatever electron hole pairs you prepared, that has to be effectively separated. Otherwise, we will not get our target. Hybrid catalytic system have higher photovoltaic activity than the individual catalysts. New catalytic system needs to develop, and here reactor engineering is important for scaling from milligram to gram scale. As a scientist, I can prepare material up to 1 gram or 10 gram. But if I want to prepare that on large scale, 1 kg or 10 kg or 1 ton, I have to take the help of engineers, chemical engineers. They will develop the methodology, reactor system, and they can produce on large scale. And this is the most important slide for the students. You can have opportunity to work at CMET. So we are taking BSc students, MSc students in physics, chemistry, and electronic science. And we have different projects. For that project, we required manpower. So that project ranging from 3 years to 5 years. So you have opportunity. We are giving stipend ranging from 45 hours to 56 hours. 45,000 to 50,000 salary we are giving, not salary, that we can stipend. Another thing is that we have one program, work-based learning program. For this, under this program, we provide internship to EWS, SC, ST, and women candidate, 10,000 for 6 months. So I am happy to see here maximum participant are women. So for women, if you are interested in research, you are welcome to the CMET. We will provide you 10,000 rupees stipend. 10,000 is not much, it is lower amount, but you can sustain in Pune, at least in 10,000. So if you have interested in working as a WBL internship, I will share my details with Vategavkar sir. You apply. Already Mujawar sir students are working with us, almost 10-15 students. They are getting benefited with the help of this work-based learning program. And for more information, you visit our CMET website, and if there is opportunity, you can apply. And finally, I would like to acknowledge Director CMET Pune for allowing me to provide or give lecture here. Then I am also thankful to IC-IASET 2026 organizers. Also thank to principal, then Zambre sir, Vategavkar sir. And this is my colleagues, S. Birane sir, Dr. Govind Umarji, Dr. Manish Shinde, Shubhangi Damakle. And these are my students who work with me. And the project funding from MIT, Moil Nagpur, and DST. This is the most important. Without these people, we cannot work. So thank you all for patient hearing.
Thank you so much, sir, for such an enlightening and inspiring keynote address. Your valuable insight and experience on interdisciplinary approach have truly broadened our understanding and motivate us to think beyond boundaries. We are grateful for your time, knowledge, and guidance. We wish for your future dream to get a Nobel Prize. So may I now invite Dr. S.H. Mujawar, Research Director, KVP University, to give Chairperson's remark.
Thanks a lot, Dr. Sudhir, for your very insightful talk on photocatalytic production of hydrogen and introducing our students with different methods for generation of hydrogen and different types of hydrogen. Also, you make them aware about the diminishing fossil fuels, and also you assure them that you are going to produce hydrogen, so no need to worry about that. So students, here I would like to tell you that those who are learning chemistry, your periodic table of 118 elements is just like a food nisa daba. You can try several permutation combinations and you can pursue your career in research. Even though you missed the opportunity in engineering or doctor field, you can earn more by coming in this particular field. So I promote you all to come for higher education and research. This will give a pleasure of learning throughout the life. So Dr. Sudhir and me, we are of same age. We are working from last 25 years. We visited several countries from government money, and we are hiring students for learning these new techniques and pursuing your career in this particular field. So with this brief, since we are running short of time, I congratulate Dr. Sudhir for working in this particular field, which is societal importance. And I urge all you students to work in this particular field, get motivated from these talks. The motto behind organizing this particular event is to motivate you people to come in the research field. So I again congratulate all the organizers My teachers, Dr. Rajpure sir is here, Dr. Zambre sir is here, my friend Vategau sir is here, Principal sir is here, Dada is here. So once again, I thank you for giving me an opportunity here. Thank you very much.
Thank you so much for sir your thoughtful remark. Now I would like to invite Dr. Tripti Shinde, ma'am, to propose a vote of thanks in very short.
First and foremost, I would like to thank our sincere gratitude to our distinguished chief guest and keynote speaker, Dr. Sudhir Arbu sir, for sharing his insightful and thoughtful ideas. Your expertise and inspired word have truly broadened our understanding and increase our interest toward a material science. I extend heartfully thank to Chairperson of this session, Dr. Mujawar sir. I also extend my gratitude to all delegates and organizer team, to all the participant, researcher and student and delegate. Thank you for your active involvement and engaging. On behalf of the organizing team, I am again extend our deepest appreciation to everyone who contribute the success of this session. Thank you all of you.
Thank you so much, ma'am. Now we are proceeding towards most awaited moment of our second session of resource person's address. May I now request Professor Dr. K.Y. Rajpure sir to chair the session. Professor and Scientist, Department of Physics, Shivaji University, Kolhapur, to chair the session of our resource person. May I now invite my colleague Ms. Rajeshwari Kamte to welcome and introduce the session.
Good morning, everyone. Respected dignitaries, honorable guests, and dear participants, it gives me great pleasure to welcome and introduce the chairperson for the third session of this international conference on interdisciplinary approaches in science, engineering, and technology, Professor Dr. Keshav Rajpure from Shivaji University, Kolhapur. Dr. Rajpure is a senior professor, scientist, and former head of physics at Shivaji University, Kolhapur, where he has made significant contributions to research and education in material science, especially in areas like thin films, solar cells, transparent conductive oxides, and photoelectrochemistry. Dr. Rajpure has authored over 250 Scopus research papers with more than 12,000 citations with H-index of 68, placing him among the world's top 2% scientists as recognized by Stanford University, which is a very prestigious scientific ranking in the world. Dr. Rajpure has mentored 20 PhD and 82 postgraduate scholars with 7 PhD students currently under his guidance. He has successfully executed 5 central government research projects and holds 2 patents. Beyond academics, he is known as ideal teacher, science communicator, and social contributor, actively promoting scientific awareness through Marathi blogs and supporting social causes through NGOs. I am delighted to announce that Dr. Rajpure sir is a prominent alumnus of our college. We are truly honored by his presence today. His valuable insights will surely enrich this conference and motivate us all to explore new dimensions of knowledge. On behalf of the organizing committee, I extend a warm and respectful welcome to you, sir, and request to take charge of the session. Thank you.
Thank you, ma'am, for such a brief introduction. May I now request our respected principal, sir, to welcome the person, Professor Dr. K.Y. Rajpure, Professor and Scientist, Department of Physics, Shivaji University, Kolhapur.
First of all, let me thank organizers, respected and honorable Dada, respected Chaudhary sir, respected Fagre sir, Dr. Vadagaonkar, and other Zambre sir for inviting me for this very important academic session of the college, the conference on interdisciplinary approach in science, engineering, and technology. So I am delighted and I have great pleasure in introducing a renowned scientist and physicist particularly. I think that is the reason why I am here, being a physicist, to introduce another physicist. So, Professor Akigo Kimura, he is a professor of physics and principal investigator at Hiroshima University, Japan. You all must be knowing the city Hiroshima and Nagasaki. These were the two cities who have suffered a lot in World War. So he is a professor at Hiroshima University, Japan, and one of our alumnus, Dr. Parale, he is a friend of Dr. Vadagaonkar. He is right now there working as a research professor. So Professor Kimura is a distinguished physicist specializing electronic structure and spin texture of novel quantum materials. Of course, this is very specialized topic. He is leading expert in spin and angle resolved photoemission spectroscopy. Like photoelectron spectroscopy, we have photoemission spectroscopy also. Spin ARPES. And he has made pioneering contributions to the discovery of and characterization of topological insulators and semi-metals. Again, here he is working on materials, namely insulators and semi-metals. Currently, he serves as a professor at Hiroshima University and holds leadership roles in major international research initiatives. Currently, he is a professor of Graduate School of Advanced Science and Engineering. Since 2020, he is a professor. He is acting director also of Hiroshima University, and he is acting director since last year. He is a senior principal researcher of the Synchrotron Radiation Research Center. This is a characterization facility. He is a vice dean of Faculty of Science, and he is carrying this responsibility since 2023. So far as research expertise is concerned, he is expert in topology in momentum space. Of course, all these research fields must be known to you people, being a budding researchers. Ultra-fast dynamics, instrumentation, and spintronics. So very similar to electronics, we have electronics based on the spin motion of the electron, is called as the spintronics. He is a PhD in science from Osaka University. He completed his PhD in 1995, long back. And the topic of his dissertation research work was electronic structure of Mn-based alloys and intercalated compounds. So this topic also belongs to material science. He has received many honors and awards, to few to cite are. Till now, more than 250 research articles in the reputed journals are to his credit, and he has published his work in highly reputed journals like Nature, Nature Communication, and Physical Review Letters. These are supposed to be high impact factor and high quality journals. And to his papers, he has received tremendous amount of citations, and he is among the top 1% of the in his field. He is a global leadership. He is having global leadership. 148 invited talks he has given worldwide. He has received a tremendous amount of funding from Japanese government. Till now, he has received 48 million Japanese yen currency for his research group. So, Dr. Kimura leads multinational research team across Spain, Germany, Austria, China, in India also, and he has collaborated extensively with so many research centers like DIPC. Such an eminent professor is with us. We are very much thankful to him for accepting our invitation to deliver an invited talk at this college. So on behalf of you all, I thank Professor Kimura and request him to deliver his talk of his interest. Please, over to you, sir. Yeah, so, and he has collaborated. Professor is with us. We are very much thankful to him for accepting our invitation to deliver an invited talk at this college. So on behalf of you all, I thank Professor Kimura and request him to deliver his talk of his interest. Please, over to you, sir.
Thank you. Mayor, can you hear me?
Yes, Professor, you can start your session.
So now I'm trying to share the screen, but it is a challenge for me. So I sent the file to
Professor, we are hearing you. You may start your presentation. You can share your screen.
actually I cannot now. There is a technical problem on my side probably. So I sent the file to Vinayak. Maybe you can open my file on your side.
Professor, when you can ready, you will start.
Actually, I cannot share the screen because
Okay.
there's a big problem on my side. You can open the file on your side, which I'm very happy. I sent the file to Dr. Inaugural. Yeah. Can I send you now on this chat?
Okay, we have received your file. Now we will start showing it.
Yeah. And can I also see that? I mean,
Yes.
I need to see that.
Just 2 minutes. I will open the link.
Yeah, thank you very much. Thank you very much.
झालं सुरू. आता ह्याच्यात जा. मिडच्या विंडो जा आणि शेअर कर screen. हा, इथून शेअर कर. हा. प्रेझेंट नाव. फुल स्क्रीन. इंटर एकदम अलीकडे. ते नाही अलीकडे. विंडोचे वरती. एंटायर स्क्रीन. हा, एंटायर स्क्रीन. हा, आता त्याला क्लिक कर. हा, शेअर. हा, आता स्लाइडला जा. हा, कर शो कर. हा, आता त्याच्याशी संवाद साधा. नमस्कार.
To the presentation mode.
इथं जर ऑडिओ ऑन केलं तर आवाज कमी येतो. ऑफ केलं
नाही, एकच स्लाइड दिसते. आता त्यांना एकच स्लाइड दिसते. प्रेझेंटेशन मोड मध्ये द्या नव्हते
हे दिसते.
नाहीतर ते स्लाइड दिसली प्रेझेंटेशन दुसरे
Yes, sir, you are audible. Actually, I can see that far, but it seems like exercise mode.
फक्त स्लाइड दिसते त्यांना. प्रेझेंटेशन मोड दिसेल ना. परत एकदा एस्केप कर. बाहेर एस्केप मार. हा, स्टॉप कर. शेअरिंग स्टॉप कर. हा, स्टॉप कर. हा, आता परत एकदा. हा, आता परत शेअर कर.
Yes, it's fine. Okay, there's that. Do you allow this to start? Oh.
एक मिनिट तिकडून शेअर कर. लेट कर. एंटर सीन. हा. आता एनेबल एडिटिंग कर वरती. हा, ते. आणि आता शेअर. आता शो कर. इथं स्लाइड शो. आता त्याला सांगा बरं विचार.
Yes, sir, you are audible. I can see the exercise mode. Could you please switch to the presentation mode?
हा, त्याला हे दिसते. ही स्लाइड दिसते. बरं, इकडे स्क्रीन केलं ना शेअर करतो.
इकडंच केलं पाहिजे.
This is exercise mode. So maybe you can just switch full screen mode. Actually, there is a button. That is for swap. Yes, swap. Yes, this one. Fine. Thank you very much. And start.
या
Okay, good afternoon, everyone. It is a great pleasure to speak at this fascinating conference. So, although I'm joining you online from Hiroshima University in Japan, and scientifically we are not separated by distance, now, because science connects across the world, I believe. I'm going to talk about topology-driven energy materials from quantum fast structures to waste heat electricity. Smartphone, your laptop, and the internet itself all share one common problem: heat. I will show that by the topology of electrons in solids, we can convert that heat into electricity. Okay, can you go to the next page? Next. So, at Hiroshima University, actually, I belong to the Institute for International Institute for Sustainability, which no need to have a meta matter, chosen as WPI-SDSM square. And I'm currently taking the role of acting director. I'd like to an overview of our institute, WPI-SDSM square. At Hiroshima University, we just started a research center. This research center 3 years ago. It's unusual, not simply physics, not chemistry, not biology. Study a common language behind them and hierarchy and not. We believe many complex systems from protein to textiles to quantum materials follow the same mathematical rules. Instead of studying each field separately, or universal design principles of matter. Please. Please, sorry. To the next page. So our institute currently includes 18 principal investigators with MPI and OPI based at Hiroshima University. We also have some visiting professors and affiliate members who actively collaborate with our teams. Okay, the members of Biofrontiers aim to incorporate interdisciplinary, experimental, theoretical approaches to biomolecular research that have never been. Yeah, I'll tell you some outcomes in Biofrontiers. Please go to the next page, please. Yes. This example, how our topological framework extends into bioscience. So in amyloid beta systems related to the Alzheimer's disease, entanglement and chirality strongly influence aggregation genetics and pathology. Through close collaboration among chemistry, physics, and advanced microscopy, we identify new amyloid topologies and aim to predict antibody binding sites. This demonstrates how abstract topological concepts can translate into medically relevant insights. Okay, next one, textiles and skins project that may be by our PI in mathematics, chemistry, and theoretical physics field studies how topology and hierarchy determines the property of flexible materials. Waste textiles pose a major challenge, and this research will durable yet degradable materials, particularly addressing potential applications in sustainable example of textile research led by Professor Inoue Matsumoto in Georgia Tech and Kotori. Here, textiles are not the final goal, but exemplars of noted chiral leather matter. Structures can be systematically like by using topological and chiral descriptors. Shared under that, so can you go back? Shared underlying principles. Principles directly link classification to rational material design and can be translated to other functional materials. This approach may enable applications in soft and biomedical materials such as surgical meshes. Noted porous materials. This project aims to realize novel porous materials by arranging molecular knots and molecular helical structures. We have already succeeded in synthesizing porous crystals and aerogels using catenants, mechanically interlocked molecules. By making use of the unique structural flexibility and adaptability inherent in molecular knots and molecular helices, we are challenging to achieve distinctly porous functions and mechanical properties, leading to innovative materials that contribute to solving environmental and energy challenges. To the next page, please. This slide illustrates how we connect fundamental structures to societal relevance. Molecular topology such as catenants allows us to control porosity, dynamics, and transport in porous materials. This structure control directly tunes material functions like gas separation, thermal insulation, and transport dynamics. It is therefore not an abstract goal, but a consequence of controllable materials facts. Addressing challenges in energy efficiency, resource separation, and environmental remediation. Next one, please. Okay, this is a work made by our colleague, Dr. Vinaya Parade. This slide shows why we need sustainable insulating aerosols. Recently, in the era of electric vehicles, battery factories and EVs is a big challenge. The battery cells are connected in series, and if one cell gets fired, that will spread over all battery, which is called as battery runaway. The battery runaway, one can use aerogel insulating sheets in between two battery cells. Damage of all batteries. Here you find the critical product find IR camera, infrared camera image of building. In the most of the energy emission is from the windows and glass slidings seen by the red bar. Replace these windows by aerogels. We can avoid this energy emission to achieve net zero carbonization goal. So thinking about future Mars colonization, but Mars surface is not habitable currently. To make the Mars habitat ready, we can use aerogel as lightweight and transparent material. To make a sustainable future, we can try to adopt aerogel as much as plastic is being used today due to its exciting thermal insulation. Aerosols are very fragile due to thin networking and hydroxyl groups 1. Two neck regions. Here we developed a new method to synthesize aerogels where the neck region can be replaced by strong networking which cannot be broken after applying force. Next page, please. At our institute is focused on synthesizing aerogel materials and metamaterials for future Mars colonization and make the Mars surface habitat Here, I want to emphasize an important concept. The key to low-power electronic light is the spin degrees of freedom in electrons and the topology of electron wave function. This applies to many classes of materials, semiconductors, permanent, and highly polarized materials. For example, even simple metals show the spin Hall effect. For low power consumption devices, magnetic devices, semiconductors enable switching control, ferromagnets enable magnetic refrigeration and memory devices. Interesting are materials with 100% spin polarization, which are promising for energy efficient memory technology. So the keywords here on my talk are spin and topology. Let me now explain what determines the material properties. Here we plot electron energy as a function of electron momentum. This is so-called the band structure. In metals, electrons occupy space up to the film level. Electrons very close to the film level conduct electricity. It means that only the electrons in the vicinity of the film level can contribute to the electron conduction. In semiconductors, as the previous speaker, I'm sorry, can you go back? So in semiconductors, as the previous speaker mentioned, the valence band is fully occupied, and the conduction band is empty. So electrons must be excited by the external stimulation such as the light. We can switch conduction on and off, which is why semiconductors are used in circuits. On the other hand, the band splits into spin up and spin down bands. If the film level crosses only one spin band on the right, the conduction electron becomes fully spin polarized. These are called half metallic ferromagnets. The spin polarization reaches 100% theoretically, which enables extremely efficient magnetic memory devices. Say, the band structure determines the function of materials. Genes determines biological function in human beings. Please. Let me can become a half metallic magnet, magnetic shape memory material, and thermoelectric material. Different elements create different band structures, and different band structures create different functions. We increasingly use artificial intelligence to search which element combination produces desirable functionality. In other words, Heusler alloys provide a model system for material design. Let's look more carefully at half metallic ferromagnets materials. The spin up band behaves as metal. Its down band is as a semiconductor. So, conduction electrons spin polarized. Extremely large magnetic resistance can be realized, which is highly promising for low power magnetic memory devices. Principal calculation on the right side of cobalt-2 manganese silicide. Structure looks very complicated. The spin up band in red amber in blue is not project development. This theoretical prediction led to experiments reporting a lead resistance as large as 2000%. If we could experimentally visualize the band structures, we could directly understand materials' functionality. For this purpose, we use a powerful technique, angle resolved photoelectron spectroscopy, shortened as RPES. We shine light onto the material, measure the energy and angle of emitted electrons, and reconstruct the band structure inside the solid. On a copper surface, a beautiful parabolic band, and from this we can also even determine the effective mass of electron, which is actually less than half of the original bare mass. So next page please. Understand such functionality, we must experimentally visualize the band structure. Like RBES to a ferromagnetic alloy predicted to be half metallic, which is called to manganese germanium. Please. Was performed at the synchrotron radiation facility in Japan, which is called Spring 8. It is a very large facility. The storage ring circumference is about 1.5 kilometers. Actually, I moved around inside the facility by bicycle. Light source allows us to perform high-resolution spectroscopy that cannot be done in a normal laboratory. Let me briefly explain the experimental challenge. The outburst is extremely surface sensitive. Unfortunately, normally we clean the crystal in an ultra-high vacuum to obtain a flat surface. However, highly three-dimensional crystal like gold, manganese, germanium, like Hoysley alloy, do not bleed easily, and for the band structures could not be measured experimentally. Recently, the synchrotron radiation beam can be focused down to about 10 micrometers diameter. So even if the surface is round, we can target the tiny flat area. Technological improvement enabled harmless experiment of these materials. Please. Can you click one? Can you make a one click? Okay, so yes, thank you very much. Another advantage of synchrotron radiation is tunable photon energy. By changing the photon energy, we can probe not only in momentum, in plane momentum, but also out of plane momentum. So we scan photon energy from 430 eV to 670 eV and moved the brilliant zone cut in momentum space, as you can see on the right side. You can see that the band structure drastically changes depending on the incident photon energy. We are actually observing the three-dimensional bulk band structure. Next page, please. The next page. Go back one. So here we show the band structures measured at two representative photon energies. You can see on the right, at 435 eV, we observe a downward dispersion whose top lies below the Fermi atom. The energy on the right, an upward dispersion, very level. And with first principle calculations, one corresponds on the left corresponds which actually corresponding to the majority has been atoms in Denmark separate, actually proves for half methodistic in this cobalt language. I mean, this result is very important. Open the way to go over spirituality classes. Go to the next page. So now, so far we have discussed the spin polarization. Next we move to the key concept, the topology of the electron wave function. This will lead us to Weier's methods and topological transport phenomena. Next page, please. We move to the topology of the electron wave function. Band crossings appear in the band structure. Something very interesting happens in momentum space. Quantity called Berry coverage emerges. So it has fictitious magnetic field acting on electrons. Of this magnetic field in momentum space bend sideways during motion. Transverse electrical responses appear, like the quantum Hall effect, anomalous Hall effect, anomalous Nernst effect. These currents can flow with very small dissipation, which is extremely important for reducing energy loss. Each. So let me suddenly show a different graph. This is a history of heat generation in computers, starting from 1950 to now. A new CPU generation appears. Heat generation increases dramatically. And new cooling technologies become necessary. We see the zigzag change after heat generation. So large-scale computers still generate enormous heat. So imagine this: if we could convert waste heat directly into electricity, it would strongly contribute to a sustainable society. Please. So now let me introduce the way of thermoelectric conversion. There are two ways. So thermoelectric conversion converts heat into electricity. Traditionally, this relies on the Zwick effect. Carriers move along the temperature gradient and produce voltage parallel to heat flow. This requires complex device structures and high manufacturing cost. This way is the Nernst effect on the right. Here, the voltage appears perpendicular to the heat flow. In magnetic materials, we can obtain this effect even without external magnetic field. This is called the anomalous Nernst effect, shown as ANE. Voltage and heat flow are orthogonal. Devices can be flexible, simple, and locals. The anomalous Nernst effect, AME, becomes sufficiently large, around 10 microvolt per Kelvin. Heat flux sensors become possible. Sensors could be attached to rotating machinery in factories, for example. If abnormal heating occurs due to misalignment, the sensor detects it immediately and stops the machine before damage occurs. The question arises, how can we design materials with large AME? The answer lies again in topology of wave function. Next page, please. So let us consider a simple model with band crossings, points. These crossing points on the left are called wild points. When the film level coincides with the wild point, large anomalous Hall conductivity appears. Interestingly, us go back to cobalt 2 manganese germanium confirm metallicity. We see several band crossings in the majority C band generate AME. Crossings are far from the film level, so a large AME cannot appear in this case. This problem, we replace germanium with gallium, which has one fewer valence electron. Cobalt 2 manganese gallium. The band shapes of cobalt 2 manganese germanium and cobalt 2 manganese gallium are quite similar to each other, but the film level shifts downward due to reduced electron number. The state is collapsed in this case, but the band crossings moves to the film level. Therefore, a large ANE is expected. Example showing that changing just one element can completely change functionality. Study, the stoichiometric cobalt 2 manganese gallium has the number of 28. In order to change the valence electron number in maybe one system, we actually prepared 11 different samples with different valence electron numbers ranging from 25.6 to 28.5 using the stoichiometry. We measure their transport properties. So here we show the anomalous conductivity actually plotted by the red mark as a function of valence electron number around 25.5. E is almost negligible. As the electron number increases, the A and E rapidly increases. Within our measured range, the maximum appears at 28.5. Temperature, the thumb power reaches about 6.2 microvolts per Kelvin. It's among the largest reported value in alloy systems. Can you click? One click. Actually, yeah, this is a diagram of the anomalous conductivity among several ferromagnetic alloys. Again, I will tell you that 6.2 microvolts per Kelvin is the largest among the largest reported values in alloy systems. This strongly suggests that the electronic structure is controlling the thermoelectric response. The next page. An important question arises. Large AME really caused by band crossings to experimentally prove it. We directly measure the band structure of cobalt 2 manganese gallium thin films using harness. This experiment was carried out in close collaboration with National Institute for Materials Science in Japan in Tsukuba. Go to the next page. The member of our collaborators, and on the right there are two persons from National Institute for Materials Science where the thin film was created. Next page, please. Samples are not suitable for spin-resolved photoemission spectroscopy, spin-resolved alphas, because they are difficult to read. In order to do the spin-resolved alphas, we need to have a relevant magnetization because we cannot apply the external magnetic field during the measurement of the photoemission experiment. So the magnetization is unstable without an external magnetic field. Film can solve this problem. We grew all of the films So here is a picture of our single tradition facility in Kyushu University campus. So here is a major band structure on the left. So showing the largest town hall. You can see a steep band crossings at the end level. To match the calculation, we shift the theoretical end level by about 70 dB. Then we find that the spin up band crossing exactly at the end level. The calculated Berry curvature on the right, so large, around the same momentum region. Actually, the largest Berry curvature takes place between X and K points, so which corresponds to the crossing point on the dispersion. Therefore, we conclude that maximization of the anomalous density effect corresponds one-to-one with topological band structures. Topology directly generates useful energy conversion. That's still a question, because we are not sure if third crossing project comes from the spin up electron or spin down electron. Theory predicts the spin up electron next crosses spin up electron causes band crossing. We have to prove experimentally. In order to prove it, we used the spin result and angle result models of spectroscopy. So next week, please. Our instrument of spin result harness. So we use the V-lead type spin detector equipped with the iron target. We switch the magnetization direction up and down and measure the scattered intensity after the iron target. Electrons are spin polarized. We observe the difference in intensity of the scattered electrons. Then finally we get the asymmetry between the intensity of the magnetization up and magnetization down. This asymmetry can be converted to the spin polarization experiment. Please. So here is the spin result photon emission experiment. We magnetized the sample and remained the magnetization without external magnetic field. So we can see that large spin polarization appears. So most importantly, the region of interest where the band crossing occurs is mostly made of the spin up part here. So then we could prove that the band crossing in the spin up part of the band structure causes the Berry curvature and causes the large anomalous density effect. Finally, I would like to thank our collaborators, our team members, including students, for this very extensive experiment and good result. So I would like to finally make a remark on the sustainability society. Next page, please. We have identified primary challenges to sustainability in energy demand, climate change, digital data explosion, and aging society. New York's horse program exposed the limits of its technological era, not only to solve crises, but to reimagine society's underlying infrastructure before it failed. Thank you very much for your attention.
Thank you so much, sir. Your talk was highly enriched and intellectually stimulating. Your session truly highlighted the importance of interdisciplinary research in solving real world challenges. We are Thank you so much, sir. Your talk was highly enriching and intellectually stimulating. Your session truly highlighted the importance of interdisciplinary research in solving real world challenges. We are grateful for your valuable time, insight, and guidance. May I now invite Professor K.Y. Rajpure for Chairperson's remark. Professor and Scientist, Department of Physics, Shivaji University, Kolhapur.
Friends, of course it was very difficult to digest this lecture to me. And I can understand, being a graduate student, not from physics, maybe from chemistry, maybe from biology, it would be tremendously difficult. And I could understand, of course this lecture was for PhD holders, PhD students, faculty members, and those who are currently pursuing research work. And this was a too much specialized topic from physics. You know, this physics is not a difficult subject, but this physics subject have made difficult by the teachers. Of course, I will not point towards Korde, Dr. Sumit, but my experience I tell. So I herewith summarize the lecture by Professor Akio Kimura. Of course, there was initially technical problem and we could not listen, we could not share his presentation, and somehow after 10 minutes we could have his lecture. Of course, this lecture was titled as Topology Driven Energy Materials. So basically he talked upon the materials, new materials, and he combined his research with a technique called as angle resolved photoelectron spectroscopy. So this has, to understand this lecture, you need to be expert, or you need to have some fundamental knowledge about X-ray photoelectron spectroscopy, then energy band structure, like density, program like any quantum espresso or other program for finding electronic band structure via density functional theory. So it is a very specialized topic. Initially, he covered what is happening in his group, particularly SK-CM square fusion, then textile, knotted and porous material. Porous material, particularly Dr. Vinayak Parle, who is our alumnus, he is working there. So he, of course, this conference is sponsored by one of the university, Yonsei University in South Korea. I personally have visited this university 2 years back, and I have visited this aerosol laboratory. I have visited Professor who is the collaborator. So I recall here my days 35 years back or so when I started my research. I worked on aerosols, and Professor Rao was my guide, and I worked on organic aerosol, resorcinol formaldehyde aerosols. So these were the days where aerosol research was initially started in India, and he talked more about inorganic type of aerosols like silica aerosols and organic aerosols also. Then he started his talk introducing spintronics, and starting with Ohm's law, J is equal to sigma E, is a V is equal to IR. V is equal to IR is a Ohm's law. So the vector form of this Ohm's law is J is equal to sigma E, where he related conductivity with relaxation time via sigma is equal to n square tau upon m. You will surprised to know I am teaching the derivation of this equation to my MSc students. Of course, it is difficult for them to understand, and it is difficult for me to teach also. So these were highly specialized topic, and he referred to the Drude model, he referred to the Sommerfeld model, where he told that the electrons which are on the Fermi level, they are contributing to the conductivity. Then he talked about the Halsner alloys and half metallic bond structure of the compound like H2IZ, basically CO2, Mn and Ge. And he showed that for spin up electrons we have one kind of band structure, and for spin down electron we have another kind of band structure. So you see, the technology has improved a lot, and we could really distinguish the contribution between spin up and spin down electrons. He focused upon angle resolved photoelectron spectroscopy. What this spectroscopy is, when you illuminate a material with the kind of radiation, it emits the electron. It emits the electron. By measuring the energy of this emitted electron, you can talk more about the material on which we have illuminated. So if you measure the energy and the other parameters of this emitted electron angle wise, then it is very easy to talk more about this. So in addition to this ARPS, he talked about the band structure calculation of half metallic and he showed spring 8 accelerator facility. As he told, he used to go around that facility on bicycle. That's what I heard. So that also is very important. He showed one of the animations where he showed 3D bulk band structure. That was very amazing to see. Also he showed, he talked about the thermoelectric generator. You see, you take any electronic machine, maybe our television or maybe our mobile, it gets heated when you see a video on mobile, it gets heated. That heat is due to wastage of energy, and that wastage of energy in the form of heat can be utilized to create another form of energy which can be used for some useful purpose. That was he proposed, and they are working on such kind of topic. Wastage, heat wasted can be converted into electricity via Seebeck effect and Nernst effect. And further he talked about spin ARPES instrumentation facility. And lastly he gave a message that are we ready to face humankind survival challenges? There are so many challenges, and I would like to tell you one of the challenges, that I am a teacher of physics, and we are like in your college also you might be facing the same problem, sir. Also to basic sciences students are not turning, they are turning to money making courses like computers, like data science, and 6-month course they are doing, and we are very difficult, we are running of the students. You see, in physics department of Shivaji University, we are having capacity, intake capacity of 80, and now we have only 32 students for MSc part first. It is very difficult to run the course. Similar is the case in this college also. For BSc 1, BSc 2, BSc 3, we are not getting. I have my own perception about why students are not turning, why students are not turning to these courses, and if they opt to this course, why they are not turning to the classes. So I have, as in my introduction it was told, I have 125 blogs. In one of my blogs I have critically reviewed this concept, of course in Marathi. You can visit my blog. Of course you can visit my YouTube channel as well. I am not advertising my YouTube channel, but you will have so many analytical techniques at one place, like XPS, like AES, Raman, molecular IR, so many techniques, lectures of these techniques I have put on that. So this existing challenge is to attract this pool of the students to the basic sciences and towards research. You know, when I was doing PhD long back, no student from Shivaji University was abroad, and now after completing some 30-35 years of service in Shivaji University, Hours means the students from physics department, almost 180 students are working in various laboratories in South Korea, in Japan, in various countries in Europe, in USA, so many, in Middle East, so many students from physics department, they are working. Dr. Parale is one of them. Dr. Mujawar, who was chairman of the previous session, of course, his colleague, Dr. Arbuj, he also has been to abroad and they have worked in the, so what we do there and why to go to abroad for doing research. You see, there you get attractive research funding, you get horizon enlarged, and very purpose of education system is to create a knowledge. So to create a knowledge, we need to know what is existing knowledge. So by reviewing existing knowledge, you can adapt to the existing knowledge, and in this process, your analytical and logical dimension of your personality will increase. And if you understand the meaning of this, then only you will not run behind the AI based jobs and you will really turn to these basic science courses. I encourage all of you to take research as your career, and I am ambassador of this college, you can suppose, because I am alumni of this college. I was student in this college in 1987 when you were not born, and now I am taking the legacy to the university and at the international level as well. So I take this opportunity to thank all those, particularly Dr. Vadgaonkar and all other colleagues, Principal Phagre, Zambre sir, and Sumit and other his colleagues for inviting me, honoring me, and of course Dada. So thank you very much and wish you all the best.
Thank you so much, sir, for your thought-provoking remark and detailed analysis of resource person speech. May I now invite my colleague, Ms. Rajeshwari Kamte, to propose a vote of thanks of this session.
Good afternoon, everyone. Respected resource person, Dr. Akio Kimura, esteemed chairperson, Dr. Keshav Rajpure, distinguished delegates, and dear participants, it is my privilege to propose the vote of thanks for the third session of this international conference. On behalf of the organizing committee, I express our heartfelt gratitude to our resource person, Dr. Akio Kimura, for the enlightening and thought-provoking presentation. Your valuable knowledge and global perspective have truly enriched our knowledge and made this session meaningful. I also extend our heartfelt thanks to our chairperson, Dr. Keshav Rajpure, for guiding the session effectively and ensuring meaningful discussions. We also thanks all the participants for their involvement. Thank you once again to everyone who contributed to the success of this session. Thank you.
Thank you very much, ma'am. Ladies and gentlemen, now we will take a short break for lunch. Lunch has been arranged for all the participants. I request everyone to kindly proceed to the lunch venue. Please enjoy the delicious lunch, and we request you to be back on the time as we'll begin the technical session of paper presentation immediately after the lunch.
Hello. Those who are participated in the oral presentation offline, they have to stay here. They have to come. I think timing is 1:30 to come this hall. And those who have participated in the poster presentation, they will come at the terrace. So whole arrangement of the poster presentation will be carried out at the terrace. Okay. Thank you.
धुली श्रीधर करून सगळं काढून येते मी नाही नाही
तो बंद करताय का
तू आहेस ना त्यांनी कसं बंद करणार
नाही निघाली
असू दे की बस की तुझं काय
Hello.
Hello.
काय होणार आहे माहिती का, आम्ही डिसिप्लिन वाईज नंबर काढणार. जेवढे आले तेवढे लावून घ्या. तर डिसिप्लिन वाईज नंबर काढणार आहे. फिजिक्स केमिस्ट्री एक आणि काय लागलीच काय त्याच्यातून 3 नंबर असतील. त्यानंतर बॉटनी आणि झूट त्याच्यातून 3 नंबर असतात. मॅथमॅटिक्स स्टॅटिस्टिक्स त्याच्यातून 3 नंबर असतात. त्यानंतर जॉग्राफी, इंजिनिअरिंग आणि टेक्नॉलॉजी आणि अदर ब्रँचेस ज्या लागतील त्याच्यातून 3 नंबर. ओके, त्याच्यामध्ये पण कॅटेगरी आहे. जे विद्यार्थी रिसर्च स्कॉलर आहेत त्यांची स्पेशल कॅटेगरी आहे, त्याच्यामध्ये वेगळे नंबर आहेत. फॅकल्टी आहेत त्यांची वेगळी कॅटेगरी, त्याच्यामध्ये ते नंबर आहेत. सर्व ते ध्यानात ठेवा. चालू ठेवा की काय अडचण नाही. काय काय प्रॉब्लेम नाही, शेवटच्या कार्यक्रमापर्यंत आणि फक्त तुम्ही तुम्ही काय करा, रिसर्च स्कॉलरची लेवल वेगळी असते आणि फॅकल्टीची त्यापेक्षा जर नाही तुम्हाला ते हाताळलं नसेल तर परत एकदा सांगतो. युजी पीजी मधून नंबर काढायचे तुमच्या विषयात. नाही युजी पीजी एकच कॅटेगरी, स्टुडंट कॅटेगरी. रिसर्च स्कॉलरची एक कॅटेगरी आहे आणि फॅकल्टीची एक कॅटेगरी. त्याचं कंपॅरिझन होऊ शकत नाही. तसं बघायला गेलं तर युजी आणि पीजी मध्ये पण कंपॅरिझन, युजीचे स्टुडंटच नाही. तुम्ही पण ऐका
emitter due to a rapid transportation and textile waste. So my model helps with them. Another example, for example, pharmaceuticals. To store the injections, we have to use a deep freeze refrigerators that cause a high carbon emission to the environment. Okay. So I have taken some numerical values to obtain the total cost. So I have considered the carbon tax holding emission for a own warehouse, at the same time rented warehouse, and deterioration emission. And these are my results. So you can see that for the crisp model the profit is minimum, for the fuzzy model the profit is maximum, but for the carbon emitted fuzzy model, though the profit is minimum, but at the same time the carbon emission also minimum. So that is economical balance. So businesses can make a profit with a small margin, but that will be helpful for the decreased carbon emission for the environmental point of view. So that is economical balance. So this is the graphical representation. So you can see that I have obtained the optimum ordinal level and total cost for the different situation. And the second graph shows that how the deterioration and the demand may affect on the carbon emission. So what are the managerial implementations? They have to adopt a green ordering policy. They have to optimize advertising for the stock turnover. They have to buffer for fuzzy regulations, and they have to prioritize warehouse energy efficiency. When they try to maximize their profit, they have to consider carbon emission due to their businesses. So what is conclusion? So integrated framework, I have successfully combined the deteriorating products which are fuzzy, and the demand function is a combination of price, stock and advertisement, and the two warehouse system at the same time. So what are the key findings? 0.38 reduction in profit is achieved, but which is a significant reduction in the carbon emission. Means profit is minimum, but at the same time margin is minimum, but at the same time the carbon emission is also minimum. So that is economical situation. So in the future scope, we have considered a multi-item inventory model, or I have considered two-way inventory model. For the future, they may have considered a multi-way inventory model for this topic. So these are the references I have referred. Thank you.
Madam, I have one question. What is the basic difference between crisp logic and fuzzy logic?
In crisp logic, we have considered a variable which are certain, but in real life, anything is not certain. There is uncertainty is always there. So for capture the uncertainty, we have considered a fuzzy model.
And here, for the parameters, you have considered a particular values.
So
what is the basic motivation behind considering?
I have considered refers many research paper, and I have considered a model which satisfy the assumptions and the basic relationship between the parameters. They must have to, means for example, for the rented warehouse, the holding cost is maximum as compared to own warehouse. So by considering various different situations, I have considered the numerical value. I have not taken the actual values for any business. I have considered from the past research paper and simulation also. Thank you. Sir, in inventory model, I have used in two-way fuzzy inventory model, I have used the inventory optimization technique to minimize the profit. They have because all observations are fuzzy, I have used non-linear methods. Thank you.
afternoon, everyone. My name is Swapnil Tatyaba Kulpe. I am pursuing my PhD under the guidance of Dr. G.D. Kokate at KVM University, Satara. The title of my research work is Magnetically Recoverable Ionic Liquid Supported Catalyst, a robust system for CC bond formation reactions. Introduction. As we know that heterogeneous catalyst plays most important role in various organic synthesis. As we know that homogeneous catalyst gives more yield as compared to heterogeneous, but the repeated use and easy recovery makes heterogeneous catalyst most effective. So here in my research work, I synthesized or developed a novel ionic liquid supported catalyst which is magnetically recoverable for organic synthesis like Suzuki coupling reaction and Hake coupling reactions. This is the synthetic pathway which I followed for the synthesis of my catalyst, in which firstly we synthesize the magnetic core and then design the various supports, and at the last palladium is supported on the catalyst. Okay? After successful synthesis of catalyst, we characterize it by using various analytical techniques. Firstly, we take same analysis in which we observe that the catalyst having the rough morphology, rough and spherical morphology. After that, we take the IDS analysis in which we found that the palladium supporting is 0.23% with, we observed that the different peaks for nitrogen, oxygen, iron, Mn and silicon also, which shows that successful formation of the catalyst. Then for thermal stability, we take TJ analysis in which we observe that at the 1000 degrees Celsius, there is 73.68% of the catalyst residue remains. It indicates that catalyst having the higher thermal stability. Then we take express analysis in which we observe two distinct peaks at 342.51 electrovolt and 337.51 electrovolt, which confirms the palladium is in second oxidation state. Then we take TEM analysis in which we observe that the average particle size is 9 nanometer and there is a core magnetic, dark core magnet present at the center of the catalyst, and remaining is a support, and at the support there is a small palladium immobilization on the surface of the catalyst. Then we take the bed analysis. At the bed we observe that the catalyst having surface area 53.56, which is lower than 5.76. 5.76 is reported for the unsupported ferrite nanoparticle, and our catalyst having the less surface area due to the supporting materials. And we observed that the catalyst having the pore size is 5.3 nanometer. Then we take X-ray analysis in which we observe the planes for 111, 221, 311, 400 and different planes which indicates the successful formation of the catalyst. After successful characterization of catalyst, we use this catalyst firstly for Suzuki coupling reaction, in which, as we know that the base having the most important role in Suzuki coupling reaction. So here we screen various organic and inorganic bases with different their mole percentage, and we observe that K2CO3 at 2 millimole we gives highest yield and at low temperature, at low time. Then we screen the catalyst loading. For this purpose, we use different mole percentage of catalyst, and we observe that for 4 mole percent we having the highest yield. These are some derivatives which I synthesized in my laboratories to analyze my work. Then after successful carried out Suzuki reaction, we use the same catalyst for the Hake coupling reaction, and as base having the most important role in coupling reaction, here we also screen the various organic and inorganic bases, and we observe that K2CO3 gives better yield at less reaction time. And also the catalyst loading, we observe that 1 mole percent of the catalyst gives highest yield, and temperature, for the temperature we get at 100 degrees Celsius highest yield. These are some derivatives of the Hake coupling reaction which we synthesized in our laboratories. After successful reaction carried out, as we know that palladium having the leaching property, so we test the leaching by using the IDS analysis after and before use of the catalyst, and we observe that there is a very minimal amount of palladium get leached during the reaction, and we carried out hot filtration test in which we observed that there is very minimum amount of leaching take place. As our catalyst is magnetically recoverable, we take its recyclability. We recover it by using external magnet and recycle for the further reactions, and we observe that after up to the 6 cycles the catalyst gives good yield. These are some references which I referred during my presentation. Thank you.
I have one question. How do you determine the particle size of the material by using experiment?
For there we have to use the Scherer equation. By using this we can calculate the particle size. But in my work, instead of that, from TEM we draw a histogram and we get average particle size is 9 nanometer.
How would you predict your component manufacturer confirmation by which characterization?
So every characterization is plays its individual role as index analysis gives elemental analysis from which we confirm the formula. Thank you.
Good afternoon. I am Poonam Ramchandra Kumbhar, research student under the guidance of Dr. Avinash Nalawade sir. Today, I am presenting our research work on green synthesized GC314 ZNO nanocomposite for the solar-driven degradation of methylene blue. Rapid industrialization has led to several water pollution, particularly from textile dyes such as methylene blue, which are toxic, non-biodegradable and harmful to aquatic life. Therefore, there is a need to develop sustainable, cost-effective and eco-friendly photocatalysts for solar-driven energy. Therefore, conventional wastewater treatment are often expensive, energy-intensive and inefficient. Therefore, there is a need to develop sustainable energy. Here we can use banana peel extract for ZNO precursor. Banana peel extract acts as a natural coagulant. The surface area for dye degradation is large in banana peel extract. It now not only reduces the agricultural waste but also increases, eliminates the toxicity of hazardous chemicals. Therefore, methylene blue is a cationic dye, that is positively charged dye, and banana peel surface have a negatively charged. Therefore, there is a strong electrostatic attraction between banana peel extract and the methylene blue dye. Therefore, surface area increases. And GC314 melamine is a primary precursor. This is the synthetic route. Then characterization technique. From XRD, we confirm the synthesis of GC314 ZNO nanocomposite, because GC314 and ZNO, both the peaks are present in this nanocomposite GC314 ZNO. Then FTIR analysis shows the functional groups. 1600 to 1500 is the stretching vibration of CH group. Then 3242 is the NH2 group. Then DRS UV analysis. Here ZNO absorb only UV light and GC314 absorb only visible light. But we have synthesized composite. That means the composite absorb both UV and visible light. That's why degradation efficiency increases. Here, due to composite, band gap is reduced. ZNO has wide band gap, that is 3.2 electron hole, and GC314 have 2.9 electron hole, and composite reduces the band gap, so efficiency increases. Then, according to same analysis, the floppy and spherical shape of ZNO nanosheet exists. Then, in TEM analysis, spherical shape of ZNO spread over the floppy of GC3N4. Then EDS analysis shows the elements present in that: zinc, oxygen, carbon and nitrogen. Then according to XPS analysis, here the elemental composition, that is carbon, nitrogen, oxygen and zinc are confirmed, and their oxidation state, that is Zn +2 and oxygen -2 exist. Then according to bed analysis, we can calculate the surface area 38.37, which is the large surface area. Here we synthesize three composites: 1s2 1s2 and 1s2 and 1s2 GC3N4ZNO has the highest surface area for degradation. Then according to kinetic study, BJH plot and H3 hysteresis loop, it shows the pseudo unimolecular first order reaction. Then this is the photocatalytic activity of GC3N4 ZNO nanocomposite as compared to first GC3N4 and pure ZNO. 1s2 ZNO GC3N4 ZNO nanocomposite has the highest efficiency. Then recyclability study. Here we perform 6 consecutive cycles. That means efficiency maximum, that is more than the 90% as it is. Then we study the scavenger study. 99% percentage of efficiency without any addition of scavenger. Then EDTA, BQ and IPA addition efficiency decreases. That is O2 and superoxide and O2 radicals are main dominant role played in degradation efficiency. Then stability state. If we perform the 6 consecutive cycle, the XRD pattern as it is the initial pattern of GC3N4 ZNO nanocomposite. Then mechanism. When sunlight exposed, GC3N4 absorbs the sunlight and electrons are migrated from conduction band to ZNO surface and reacts with O2 and form the superoxide radicals. And in GC3N4, holes are form the hydroxyl radicals. These reactive oxygen species combines with the reactive oxygen species and formation of the breakdown of the methylene blue dye into harmless product, that is CO2 and water. Then in this way we have performed the lab work and we analyze different parameters using water analysis, and we conducted from Isarkaranji textile dye industry wastewater and use the nanocomposite and optimize the parameters pH, BOD, COD, TO, hardness and TDS of water. This is pictorial presentation in our lab work before degradation and after degradation. These are my samples. Here this is the sun meter, use the sunlight intensity. Here we use natural precursor banana peel extract, and sunlight is a natural energy, that means sustainable energy source. And 98% efficiency of GC3N4 ZNO in only 40 minutes. That means it is highly stable and renewable energy. Then our future planning are target for funding agencies, provide research-based data for industrial wastewater solution, highlight the growing demand for sustainable and green technologies, and offering wastewater treatment. Thank you. You may ask any question.
How you synthesis the nanocomposite?
From banana peel extract, we synthesize ZNO and zinc acetate as a other precursor, and melamine is for GC3N4. And then this mixture is heated at 550 degrees centigrade in furnace, and then grind this mixture.
What are the advantages of these?
In industrial wastewater, some dyes are dissolved in, such as methylene blue, methylene orange, etc. And these dyes are removed from this catalyst. Yes.
How you are going to remove those nanocomposites from that water? Because those are solid.
Yes, recyclability. Yes, sir. We say these particles are centrifuged after using, and then after centrifuge, filter it. Then use. Yes, sir. Washing with distilled water and alcohol, and then centrifuge. Yes.
How you are going to remove that nanoparticle from environment? Because you are going to act with water body.
Nanocomposite are not removed. Methylene blue dye is removed, and we
Those particles are going to remove in that
some part of nanocomposite absorb the methylene blue dye, but nanocomposite we are also again collected. And after,
are going to environment, are you sure?
yes,
Those are going to dissolve in that water. Those are not going to dissolve. They're going to remove. How you are going to separate that from that water?
yes.
Those are nano inside. So how?
These nanocomposite are settled down in the surface of this water, polluted water, bottom of the polluted water, and then we collect it and then treated with alcohol and distilled water and again centrifuge, and after this XRD is at same as first pattern of this XRD. Okay, thank you.
Good afternoon, one and all. Myself, Murugendra Tanaji Guru, and I have done this research project under guidance of Sandeep Vadegaonkar sir. So, the title of my research work is Hydrothermal Fabrication of Manganese Cobalt Tungstate for Highly Efficient Supercapacitor Devices. Over a period of time, we have seen that many attributes of human needs have evolved. Today, we demand electricity because 85% of gadgets we use are all electrified. So, although there are number of resources to derive electricity, but challenge lies in storing that all things. And more precisely saying, we want a faster and a denser vessel that can store all the electricity that we have received from renewable sources. Because number of times what happens, the energy input is higher in peak hours, but at the same time, when you want to store it, you do not have such capacity. So for capacity building, I have developed a material as an electrode which will fastly store all the charges as well as have a large volume. As well as have a large energy density. So this is the introduction. We required electricity in all the localized stuffs till the communication stuffs, because the supercapacitor, when you use it, you want energy output in higher value at the same time, like mass communications, like electric vehicles. Normally in electric vehicles, regenerative braking systems in which the energy utilized while braking is also again converted into mechanical energy using these supercapacitor devices. The objective was to synthesize manganese cobalt tungstate because it is firstly the novel material. Second objective was to characterize the structural characterization of this material. Third was to electrochemical analysis, and lastly I fabricated a device also. The hypothesis was that transition metals and tungstate group in a synergistic way will enhance conductivity and surface area through its porous structure, which can lead to improved supercapacitor performance, boosting energy, both energy and power density, which is proved later in result sections. The material showed N-type semiconductor conductor. It was low cost because all the metals we use is transition metals, and that is easily available all throughout the world, and discretely available, not like lithium ores are only in China or in Afghanistan valleys. It is throughout the world. So I have used transition metals, which if we are going to scale up, then we can understand. You can understand that there will be no monopoly among nations to use this material. Second thing is that hydrothermal process was used because it aligns with SDG goal number 12, that is responsible consumption and production at the same time. So, and water is used which is non-toxic, and the setup is much easier, which can be scaled up later. In experimental section, I use precursors for manganese source, cobalt and tungstate sources, manganese sulfate, cobalt acetate, and sodium tungstate. The autoclave heating of 3 hours for 70 degrees Celsius was done, and further the vacuum filtrate were washed the impurities, and further it was annealed for 3 hours at 500 degrees Celsius to get a more crystalline structure and well-defined grain boundaries. In structural analysis, you can see that manganese cobalt tungstate is successfully synthesized, as at 30 radian you can see the strong peaks and broader peaks showing the polycrystalline nature of this material. In same images, you can see that cauliflower-like structure is being produced. Also, you can see that a porous structure in which the charges are being stored. These are seen, and this is all at micro level because these readings are these images are taken at 10 micrometer. It is not in nanometer. It is in micrometer. So these are all micrometer structures, microstructures. In electrochemical analysis, you can see that CV curve shows that redox behavior of this material is seen, along with GCD curve, quasi-triangular nature of graph, so that it also shows battery-like structure, battery-like behavior of this material. Because if you see charging peak at 200 seconds, and equal time is given for discharging till 400. So it shows that the material can slowly give out that output along with maintaining the power efficiency. Specific capacitance calculated using this GCD curve was 680 at scan rate of 10 millivolt per second square. Millivolt per second. And EIS stability, you can say that initially the real impedance is lower till 3.5, but as soon as 3.5 is overcome, the imaginary impedance is higher, but still the real impedance is low. It shows that no solution resistance or no material resistance was seen in this. And stability was best, it was 97%. It shows that over 5,000 cycles, the material is still 97% stable. Sorry. Okay. And when I fabricated this device, which is an asymmetric device, because as a counter electrode I use activated carbon electrode, and as a working electrode I use my material with, and it showed that in CV curve it was showed that redox nature was seen, but this time the potential window was on the positive side, not like the 3 electrode system in which on negative side potential window was seen. In GCD curve it was again showed that quasi-triangular nature is seen. EIS showed that internal resistance for this solution, for this symmetric device was less, along with stability, with Coulombic efficiency was 100%, and the material efficiency, material capacitive retention was 94%. So in conclusion, this material was successfully synthesized, and this is novel material, so it was harder for us to make sure that it should be synthesized. Fabricated device showed that energy and power density was 14 watt-hour per kg and 1100 watt-hour per kg with 94% capacitance. XRD patterns confirm that polycrystalline nature is seen with same images showing cauliflower-like morphology. And lastly, the 3-in-3 electrode system, you can see that 680 Faraday per gram of capacitance, specific capacitance was seen at 10 microvolt per second of scan rate. Thank you. Any question? Supercapacitor. This material can be used in large number of applications, especially those areas where the power output is higher along with energy output. I'm giving you an example. If you see electric vehicles, if you want to boost its speed from 0 to 40, you want instant burst of energy, and at that places you need supercapacitors. They can give you a higher output in less interval of time. It is just like a vessel with bigger mouth and deep volume. Simple. Economically favorable 100% नाही म्हणताय ना, पण reusability जर वाढली तर economically favorable आहे, आणि ट्रान्झिशन मेटल्स आहेत म्हणून ते हे पण करू शकतो आपण, गॅल्वनायझिंगली आपण गॅल्वनोस्टॅटिकली आपण सेपरेट पण करू शकतो फर्दर. क्रॉप करायसाठी मी विचार करतो की एमझिन मटेरियल माहिती, त्या एमझिन मटेरियलचा यूज करून आपण एमझिन @ मॅग्नेटिक कोबाल्ट टंगस्टेट हे मटेरियल बनवू शकतो. कारण की एमझिन कसं आहे, फास्ट चार्ज डिस्चार्ज करतं आणि एमझिन स्वतः चार्ज स्टोअर पण करतं, इंटरफेस टाईप. सो एमझिनचा यूज केला तर आपण ते फॅब्रिकवर पण कोट करू शकतो, जसं की आपल्या शर्ट पॅन्ट्सवर. म्हणजे आपल्याला जिथं पाहिजे तिथं एनर्जी आपण हे करू शकतो, प्रोड्यूस करू शकतो. हो, किसनगर महाविद्यालयामध्येच मॅग्नीज कोबाल्ट टंगस्टेट. मृगेंद्र तानाजीगुरू. मृगेंद्र. Yes. It is not a catalyst. I have used it as an application for electron material. Because manganese is atomic number 25, so it have variable oxidation state along with cobalt. Cobalt actually gives stability, and more stability is given by tungstate group, because on tungstate group there is cloud density of electrons that gives a stronger base for manganese and cobalt to restrain their places in material. It is not separate. You can say that Mn is doped because ionic radius of Mn is smaller. Sorry, ionic radius of Mn is bigger than cobalt radius. So you can say that Mn is doped in this material. But when you go on XRD, then you will confirm that it is a composite material. More precisely saying, it is composite material. Thank you.
आणखीन कोणी पार्टिसिपंट्समध्ये केमिस्ट्री किंवा फिजिक्स डिपार्टमेंटमधून बाकी राहिलेले आहे का? ठीक आहे. यानंतर आपण लगेचच वेळ न दवडता झू आणि बॉटनी ह्या डिपार्टमेंटचं ओरल पेपर प्रेझेंटेशन चालू करूयात. वेळेअभावी आपण थोडं फास्ट जातोय. केमिस्ट्री आणि फिजिक्स सेशन या ठिकाणी संपलेलं आहे असं मी जाहीर करते. सो डॉक्टर विजयश्री हेमके मॅम आणि डॉक्टर शुभांगी वस्के मॅम यांना मी विनंती करते की त्यांनी व्यासपीठावर यावं. So, Dr. Vijayashri Hemke ma'am is an associate professor of zoology and an active research supervisor guiding multiple PhD scholars. She has published 32 research papers and completed 2 major research projects. She holds 2 patents and has 7 authored books in her field. She also served as a reviewer of 23 international science journals. And Dr. Shubhangi Vaske ma'am is from Department of Botany at SM Joshi College, Hadapsar, Pune, and has served as a former in-charge principal at Trimurti Women's College. She has published several research papers, authored 2 books, including a syllabus-based reference books also, and successfully filed 2 patents related to medical plants and agriculture. So, Patil कुठे? मी झुलॉजी डिपार्टमेंटचे चव्हाण सर यांना विनंती करते की त्यांनी डॉक्टर विजयश्री हेमके मॅम यांचा पुष्पगुच्छ देऊन या ठिकाणी स्वागत करावं. धन्यवाद सर. तसेच त्यांना मी विनंती करते की त्यांनी डॉक्टर शुभांगी वस्के मॅम यांचंही पुष्पगुच्छ देऊन या ठिकाणी स्वागत करावं. धन्यवाद सर. डॉक्टर हेमके मॅम आणि डॉक्टर वस्के मॅम यांचं मी या ठिकाणी शब्दसुमनांनी स्वागत करते आणि आज त्या झूलॉजी, बॉटनी, बायोटेक्नॉलॉजी अँड मायक्रोबायोलॉजी या सर्व सब्जेक्टच्या पेपर ओरल पेपर प्रेझेंटेशनसाठी या ठिकाणी रेफरी म्हणून लाभलेले आहेत. मी त्यांना विनंती करते की त्यांनी व्यासपीठासमोर आसन व्हावं. या ठिकाणी जे कॅन्डिडेट्स आहेत लाईफ सायन्सच्या ओरल पेपर प्रेझेंटेशनसाठी त्यांची मी एकदा नावं पुकारते. त्यामध्ये कोणाचं नाव नसेल तर कृपया त्यांनी मला कळवावं. जगताप वृषाली सुनील, बायोटेक फील्ड आहे त्यांची. त्यानंतर डॉक्टर प्रतीक सुनील कांबळे सर, देन खुशबू मनोज ओसवाल झुलॉजी डिपार्टमेंट, आणि भक्ती वायदंडे बॉटनी डिपार्टमेंट. या व्यतिरिक्त आणखीन कोणतं यामध्ये नाव नाही आहे का? त्यांच्याकडे ठीक आहे, चालेल. असे 6 कॅन्डिडेट्स या ठिकाणी आहेत झुलॉजीमध्ये. तुमचं नाव काय आहे? नम्रता अडसुळे. ओके, झुलॉजी. ठीक आहे, चालेल. डॉक्टर प्रतीक कांबळे प्लीज. आणि सर्व कॅन्डिडेट्सला मी या ठिकाणी विनंती करते की प्रत्येकाला फक्त 5 मिनिटाचा वेळ या ठिकाणी भेटणार आहे. 4+1 असं या ठिकाणी आपण टाईमचं डिव्हिजन केलेलं आहे. मॅडम
Hello. Good afternoon, everyone. I am Dr. Pratik Sunil Kambaya from LBS College, Satara. I have completed my research work under the guidance of my research guide, Dr. Respected Swarupa Amit Patil, Madam. The title of my research work is Nanoparticle Behavior and Dynamics based on concentration, pH, and temperature variations on the size of nanoparticles synthesized from highly medicinal plant Dreamia indica. So basically I am working on plant disease management by aerosol assisted nanosprays, but the primary thing is that we must have to produce or prepare nano-size nanoparticles. So that's why I will start from basics. So for that I have used Dreamia indica. This is my plant which I have used as a reducing agent. Here we can see that this Dreamia indica belongs to family Aspergillus, genus Dreamia, species Dreamia indica. The morphology of that plant is like it is a bulbous herb with radical leaves. Here we can see the radical leaves, and these are the rooting disc it having. So this is a flower and this is a fruit of Dreamia indica. So we can say what are the nanoparticles? So nanoparticles are microscopic in size. They are having a high surface to volume ratio, and those are diverse applications. Like I am using these nanoparticles for plant disease management. Here we can see that the nanoparticles can be synthesized by chemical method, route, physical method, route, and biological method. So here I am going to prefer the biological method of nanoparticle synthesis. Here those nanoparticles are eco-friendly, which are synthesized from plants, microbes, and other living entities. Here we can see the size of nanoparticles, which ranges between 1 to 100 nanometers. We can say for 1000, but for plant disease management I refer 1 to 100 nanometers of size. Then materials and methods. Here primarily I have collected the plant, then prepared a plant extract, then I have synthesized the nanoparticles, then I have characterized them, and the main motive of my study is to see the effect of concentration of plant extract, pH of reaction, and temperature of that reaction on the size of nanoparticles. So basically I am going to deal with size of nanoparticles. So here collection of plant material. I have collected Dreamia indica from Devdari Amberi. The chemicals were used from Thomas Becker's, and this is a silver nitrate compound. Extraction process. Here we can say that for plant extraction preparation I have first of all measured the leaves, then I have heated it and filtered that particular plant extract by using watermelon filter paper number 1. Then this is the schematic diagram of nanoparticle synthesis, where I have taken in burette 20 ml of 10, 20, 30, 40 and 50% plant extracts as a separately. Then I have taken in conical flask of 1 millimolar H2O3 solution. Then I have taken these that flask on that particular magnesium with hot plate, and I have run separate 5 reactions where the temperature was 40, 50, 60, 70, 80 degrees centigrade. where the pH was maintained as 4, 5, 6, 7, 8 separately. Those are the 5 reactions. Then this is an schematic diagram where the steps are there, which I have discussed earlier. Then for characterization of those particular nanoparticles, I have used UV visible spectroscopy as a primary characterization technique. Then I have observed the X-ray diffraction peaks of that particular crystalline nature of those nanoparticles. Then I have observed those by using transmission emission electron microscopy, which is TEM. So here we start the results and discussion, in which we will see the collection of plant material, biological synthesis, characterization, and effect of pH, concentration, and temperature. So first of all, collection of plant material. The Rhema indica Roxburgh Jasov was collected from Devdari Amberi district, Satara state, Maharashtra. These are the GPS counts. This is the altitude in feet, and it is the accession number where PSK 003. So here we can see the schematic diagram of nanoparticle synthesis. Here this image shows the characterization of Rhema indica based silver nanoparticles, which is 10% extract, pH 4 and 40 degrees of temperature. So here you can see that. In second, we can see that there is a 20% extract, pH 5 and 50% temperature. Here we can see the visible spectroscopic graph or peak. We can see the X-ray diffraction patterns, and these are the TM images. Here we can also see the results of characterization of Rhema indica based silver nanoparticles, which are 30%, pH 6 and 60 degrees of temperature. They are 47 and 70, and these are the results of characterization of those particular nanoparticles. So basically I want to say that effect of concentration, when we are going to increase the concentration, those are very effective for the synthesis. Here we can see that as the plant extract was increased, the rate of reaction also increases and the size of nanoparticles get decreased. Next, pH. Here when we are going to use the basic pH, the nanoparticles reaction happens and the basic pH is suitable for the synthesis of nanoparticles. Here we can see the temperature. I have checked 10, 20, 40, 50 degrees of temperature. Here I have seen that 40 to 50 degrees centigrade is the best temperature for the synthesis of nanoparticles. Then effect of concentration of pH, temperature on size of nanoparticles. Here we can say that from present study, it is clear that optimized concentration, pH and temperature of reaction has important part for successful synthesis of nanoparticles. Then we can say that these parameters during green synthesis play a predominant role, and desired nanomaterials can be synthesized or designed. And last, the summary and conclusion. Here, the research emphasizes the critical significance of fine-tuning reaction parameters like concentration, pH, temperature, which play a pivotal role in the enabling the synthesis of nanoparticles. And lastly, this process provides a foundation of crafting nanomaterials tailored to specified requirement, rendering them versatile for a wide array of applications. These are some references. Thank you. Are there any questions, please? I'm a faculty, but I have done my research work under my guide Surabha Patil. So I am presenting my PhD work. Yes, as a teaching. I am a faculty at LBS College, Satara. Actually, ma'am, I am working on plant disease management. I have prepared a specific spray of nanoparticles. But when I am going to deal that nanoparticles with plant disease, suppose there is a fungal disease, so I must have to ensure that the nanoparticles are very small in size, because when we are going to synthesize nanoparticles by chemical or physical method, we can control the size, but during the biological synthesis we cannot actually control the size of nanoparticles. So basic was to control the nanoparticles. That's why I use this route to show you. And Dremia is, actually I have worked on two plants. First is Bohina and another is Dremia. So Bohina was dicot and Dremia is monocot. Basic is monocot plant, and that Dremia indica having the phytochemicals which are used as a reducing and capping agent. So for biological synthesis I use Dremia. Actually my basic regarding selecting Dremia was to take a monocot plant. So I have assessed all plants, but I want to eager to have a work on this plant, so I have chosen this Dremia. Thank you, ma'am.
Good afternoon, everyone. I am Bhakti Ganesh Vaidande from BSc second year. I can done my project under guidance of Dr. Damayanti Ingavle miss. So the name of my project is the physicochemical properties of an epiphytic ferns in the Western Ghat at the Mahabeshwar hill station. In the introduction, we all have know that the Mahabeshwar is the highest hill station in the Western Ghat. There is 59 species belonging to 273 genera of an epiphytic ferns. So here we all have know that the soil can play the important role in the growth and development of the plant. So the soil growing of plant. So here the epiphytic soil is having the highly nutritional value as per the ground soil. The epiphytic ferns are non-parasitic, but they are depend on the other plant for their growth and development. So here we can do the soil fertility conducting by in the materials and methodology. We can collecting the soil sample from Mahabeshwar hill station of 3 species of rhizomes. Then we can spread that epiphytic soil and ground soil in the polythene sheet and dried it at 25 degrees Celsius by the electrical blender. And then we can discard it to particle, and other we can stored by the air pack. This process we can done in the Buhin's Karkhana. Then in the result and discussion we can observe that the pH, then water holding capacity and organic carbon in the epiphytic soil is greater than the ground soil, and the micro elements also present are having the highly values rather than ground soil. And in conclusion and reference we can say that ki epiphytic soil is having the highly nutrition value as per ground soil, and it is also having the medicinal values also, where further studied for that, but it can having medicinal values. And these are references. Thank you. Sorry. Actually they are having more nutritional value as per other ground soil, so it is being useful to treat plant diseases. They are having highly NPK values. Thus Aspergillus, Microserum, epiphytic plants, which we have studied Western Ghat, Mahabeshwar hill station. Miss, actually ज्यांच्या अंडर केला त्या
Good afternoon, all of you. Myself, I am Mandar Mohan Bise, student of TYBSc from Kishangarh Mahavidyalaya, WAI. Today I am going to represent my research article on recycling of the biodegradable waste through the vermicomposting in Kishangarh Mahavidyalaya, WAI. Now this is an abstract of my research. Introduction. Nowadays, the world's biggest problem was management of the solid waste produced. The several techniques are arised for the management of this solid waste, but it is essentially or economically important to manage the solid waste. Consequently, we can use the vermicomposting method for the management of solid waste in our college campuses. Material and method. About 3,500 species of earthworms are arises during I found during my research. From that, I can choose the one species that is Escherichia fetida for the vermicomposting. This species is commonly known as the red worm, also grandling worm, and reproduction rate of that species is fast. Also, it produces the cocoon daily. These are some photographs of my research paper. In this photograph, for this vermicomposting, we can arrange totally the 4 beds for the vermicomposting. 3 beds are the proper for the vermicomposting and another one is for the storage of the biodegradable waste. These beds are the 12 feet into length, 3 feet into the width and the 2.5 feet into the depth. These beds are arranged in the north corner of our college campuses. Primary material needed for this vermicomposting is obtained from our college campuses, including the garden waste, mainly the dry leaves, dry grass, also canteen waste and the paper. All this material is poured into these 3 beds and then covered with dry grass, dry leaves and 10 kg of the conduct slurry and watered it daily. Watered it daily. Then watering is stopped at the time of the harvesting. So the brownish colored or the dark layer of the vermicompost at last is then get collected and poured into the plastic bag and used as the biofertilizers for the gardening plant. This is acknowledgement. So I am very thankful to our principal of the college, Dr. Gurunath Fagre, and the head of department, Dr. Jhambre sir, and the guidance Ashwini Shevali miss for the continuous support during my research. Thank you. These are some references.
How you differentiate soil and this vermicompost? Normal soil and vermicompost.
Normal soil have the weight, but vermicompost ready in 2 months is is light in weight. So, for example, when we dip the soil in the water, common soil is get at the
From that bed, how do you extract the vermicompost? बेडवरती तुम्ही त्याच्यामध्ये वेस्ट टाकलं सॉलिड वेस्ट 2 महिन्यानंतर त्यातनं वर्मिकम्पोस्ट सेपरेट केलं ते कसं सेपरेट केलं
बाय आम्ही त्यामध्ये वर्मिकम्पोस्ट चाळून साईडला काढलं
आणि वर्मी वॉश
वर्मी वॉश पण मिळाला
तो कसा सेपरेट केला
तो वर्मी वॉश त्याच्यानंतर पूर्ण ही काढल्यानंतर जो खाली राहील तो वर्मी वॉश म्हणून घेतला
किती मिळाला एका बेडमध्ये किती लिटर
एका बेडमध्ये तरी वर्मी वॉश मिळाला तरी 50
मॅक्स 1 लिटर हाफ लिटर 1 लिटर ठीक आहे ओके
थँक्यू.
Good afternoon, one and all. My name is Namrata Adsure. I am the student of Masters in Zoology under the guidance of CB Zamdade Miss, and this is my project named Modulatory Effect of Punica granatum peel on dimethoate induced biochemical alterations in liver and kidney of mice. Punica granatum peel is the scientific name of pomegranate. This is the introduction. Dimethoate is an organophosphate pesticide used in controlling many pests of variety of crops as a systemic and contact pesticide. The toxicity of organophosphate insecticide result in negative effect of many organs and systems as a liver, kidney, heart and nervous system of rat. The liver and kidney are a vital organ are involved in drugs metabolism, detoxification and excretion in experimental animals and attacked by the organophosphate compounds. And Punica granatum and the juices have the great medicinal uses. These are used as an antioxidant on the liver and kidney of mice. Antioxidants are the compound responsible for free radical scavenging in the body. They protect the organism from oxidative modification of cells and tissue. And as I have said before, pomegranate have the great antioxidant potential due to high level of phenolic compound, flavonoids, etc. Parameters that we have taken, that is body weight of the animal that we have taken in gram, and estimation of protein level in adult mice. These are the materials and methods. Dimethoate that we have collected from local market. These are the peels of pomegranate fruit, and further we have made the powder. Mice were divided into experimental design. There mice were divided into 4 groups. Here we can see the 4 groups and 4 categories that mice have divided, and methods method that is Lawrence method 1951 that we have used. Estimation of protein. This is the result that in our experiment or in our project. First of all, at the last, dimethoate and dimethoate plus peel. Here we can see that body weight is lower, and after in the second number graph, we can see that the protein level has increased due to pomegranate peel extraction. Means after giving peel extraction to that animal, protein content is increased, and further that there is means it was under pesticide, so weight has decreased before, and after giving that, protein content has increased. Conclusion. So according to this experiment, pomegranate peel extract, which is an inexpensive, easily available, and can increase oxidant enzyme, which has ability to protect against oxidative stress and have antioxidant effect on dimethoate induced hepatorenal damage. These are the references, and that is it. Thank you, ma'am. Thank you for. Ma'am, sorry, I don't get it. Your question. Conclusion. Okay, according to us, the treatment with pomegranate peel. Ma'am, डायमिथोएड हे एक पेस्टिसाइड आहे. तर पेस्टिसाइड हे जे आपण माईसवर इंड्यूस्ड करतो, तर त्याच्यामुळे त्याचं वेट जे आहे ते डिक्रीज झालेलं आहे. आणि पोमोग्रॅनेट पील हे एक त्याच्यापासून आपण जी पावडर बनवली आणि ते त्याला दिलं आपण, स्पेशली लिव्हर आणि किडनीच्या ऑर्गनवर म्हणजे आपण त्या इफेक्ट जास्त होतो ना, कारण लिव्हर हे जास्ती करून डिटॉक्सिफाय करतं किंवा मेन ऑर्गन आपण कन्सिडर करू शकतो. तर ते दिल्यानंतर त्याची प्रोटीन लेवल जी इन्क्रीज झाली आणि त्याचं वेट पण इन्क्रीज झाले, म्हणजे मेटाबॉलिक रिॲक्शन जी आहे ती फास्ट झालेली आहे रॅटवर आफ्टर गिव्हिंग पील, म्हणजे काय पोमोग्रॅनेट पीलची पावडर दिल्यावर. असं हा तो त्याचा रॅशनल आहे. पेस्टिसाइड. येस येस. ॲक्च्युली हां, पण ॲक्च्युली इथे काय येतं की म्हणजे आय गेट इट, बट आय गेट इट. थँक्यू.
Good afternoon, one and all. I am Dr. Chandni Zamdade, Assistant Professor, Department of Zoology, KBP University, Satara. Today I am going to present a topic on ameliorative effect of pomegranate, Punica granatum peel and juice extract on dimethoate-induced renal dysfunctioning in the aged mice. Next. Next is the introduction of my topic. Actually, aging is the universal, irreversible process in all vertebrates and animal also. The dimethoate is a organophosphoric pesticide which is used in controlling many pests which obtained in the crop fields as a systemic and contact pesticide. This organophosphoric insecticide causes free radical production by the oxidative stress and alter the antioxidant enzymes. The toxicity of this toxicity of these organophosphoric insecticides result in the negative effect on many organs and systems also, like liver, kidney, brain, and nervous system. The toxicity of organophosphate is always evaluated by assessment of some biochemical parameter alterations and histopathological changes in the tissues. The primary mechanism action of this pesticide is based on inhibition of acetylcholine esterase activity in the brain. The kidney is one of the vital target organ involved in the drug metabolism, detoxification, excretion in the experimental animals, which is attacked by the organophosphate compounds. The Punica grantum peel as well as juice have a great medicinal interest and rich source of antioxidants due to high level of phytochemicals. The antioxidants are the compounds which are responsible for the free radical scavenging in the body, and they protect organism from the oxidative modifications of the cell and tissue. The present study was aimed to investigate the dimethoate-induced raise in serum creatinine level in the blood as well as histopathological effect on the renal tissue, and to observe the protective effect of Punica grantum peel and juice extract in the aged mice. The parameter which I have studied, the first one is the estimation of serum creatinine level in the aged mice, and the second one is to study histopathology of kidney of mice by HE technique. These are the material and methods which I have used for study. The first one is the dimethoate, which is collected from the sigma altitude. Then second one is the collection of pomegranate peel sample. For this collection of fresh fruit were collected from the local market of the Satara. Then fruits was washed, then peel out, then peel were dried into shade. Then prepare by using Soxhlet apparatus, alcoholic methanolic extract is prepared. Then fresh juice the areas were separated and fresh juice is prepared and further used for the next study. Then collection of the animals. For this study, musculus animal which is having the age 80 to 20 month, which is collected from the Rajaram Bapu Pharmacy College, Kasegaon, and this whole study is sanctioned by the Animal Ethical Committee, which was held in 2021. Then collection of the blood sample. For this collection of creatinine, the blood is collected from the eyes. The retroorbital plexus method was used to collecting the blood. And next is the kidney of aged mice. The kidney were collected by dissecting out the mice, and the sections were made. Then experimental design. Mice were divided into 6 different groups. Group 1 is the control group, which fed with the 0.5 ml distilled water per kg per body weight of the animal. Second group is peel extract group, which fed with the 200 mg per kg body weight of the animal. The group third one is the juice extract group, which fed with the 3 ml at a dose of 3 ml per kg body weight of the animal. Then group 4th is the dimethoate toxicated group, which fed with the 15 mg per kg body weight of the animal. Group 6 is dimethoate plus peel extract. For the first 15 days, dimethoate induced this animal for the 15 days at a dose 15 mg, and then after 15 days, the 200 mg per kg peel extract given to the same animal. Then group 6 is served as a dimethoate plus juice group, which fed with the dimethoate for the 15 mg, and then after juice extract 3 ml for the next 15 days. Can I continue, ma'am? Okay, thank you. Then methods. The first one is the pomegranate peel extraction by using Momin method. Then second one is pomegranate juice extraction by Fariametal. Then third one is estimation of serum creatinine by SAS method. And the fourth one is the histopathology of the kidney by HE technique by Harris method. Then this all study is statistical analysis. The obtained results were presented by mean plus standard deviation, and ANOVA is used. The resultant analysis I used to this graph for, I would like to use this graph for explanation. Here we can see in the graph number first, after giving the dimethoate treatment, the creatinine level is increased statistically when compared with the control mice, and after giving the treatment with pomegranate peel extract as well as the juice extract, both in adult and old mice, this increased the dimethoate, increased the creatinine level is decreased decreased down in both adult and aged mice after giving the treatment with pomegranate peel and juice extract. This happened due to the antioxidant and secondary metabolites which present in the pomegranate peel as well as the juice extract. This may happen. Then next is the histopathology of kidney. Then conclusion of my study is, the study revealed that pomegranate is a medicinal plant and mainly its peel and juice which contains the secondary metabolites and has a multiple protective agents can protect the humans against oxidative stress and reduce consequently risk of diseases and prevent the disease propagation in our body and the kidney. And according to us, the treatment with the pomegranate peel and juice extract, which is inexpensive, easily available and can increase the antioxidant enzymes which has ability to ameliorate the oxidative stress and have an anti-toxic effect on the dimethoate induced renal damage. These are some references which I have used, and thank you everyone for attending me, your attention. Thank you everyone. Madam, these doses were set by using previous year reference papers, because Animal Ethical Committee not giving us to permission to going towards the LD50. So these are by using the data which is available in all elsewhere journals. I use these doses, and according to WHO also. Because this dimethoate is actually banned in our India, but it is used in farmers, or used by the farmers by another trending name like Tafgar or Tatarogger, and it is used again against the termites or crop fields, or by increasing the weight or increasing the numbers of crops. It is again and again used on the crops, but it is also it is banned in India. Anyone? Any question? Yes. तो ती माझी स्टुडंट आहे, प्रोजेक्ट्स तिला अलॉट केलेला आहे आणि तिचं ॲक्च्युली काम आहे ते ब्रेनवर बघणार आहे आम्ही, बिकॉज दिस डायमिटोएट इज तिचा प्रोटीन कंटेंट बॉडी वेट पाहिलं, त्यानंतर मी आणि तिचं ॲडल्टचं काम आहे मॅडम, आणि माझं जे काम ते एजिंगचं आहे. तिचा जो ॲडल्ट आहे तो 4 to 5 month एजचा आहे, अँड माय माईस वॉज हॅव्हिंग एज 18 to 20 month. येस येस, पोमग्रॅनेट पील अँड ज्यूसचा. Thank you everyone, thank you.
Good afternoon, all of you. My name is Rushali Sunil Jagtap. I am a MSc student. My topic name is an experimental study on the formulation and evaluation of herbal products. All herbal substances are found in the market, and not only market, we can grow in our farms. The use of cosmetics, we can see in cosmetics many toxic chemicals are used which are harmful to our skin and hairs. Hence, I am used herbal and Ayurvedic technique to make these products. we can see in our Ayurveda and ancient culture, there are many therapies and many products are included as herbal products. These are traditionally used for health and cosmetic purpose. Ayurvedic products are growing demand in pharmaceutical and cosmetic industries. The main objective of this topic is to enhance our traditional beauty, like in mentioned in Ayurveda, like Atharva Ved and many other books are included. These are materials which I use for those products. There are my 4 products like hair pack, hair oil, face pack and soap. We can see in the market many dyes and hair packs in which use many chemicals, toxic chemicals which are harmful to our skin and hairs. It causes irritation, redness or hair fall. In my hair pack, we can use ingredients. Those are available in our market. These are methodology, collection of plant material from medicinal plants, evaluation and purity and quality of raw material by morphological, physical, chemical techniques. All drugs were made into a powder and according to formula mentioned, we can prepare those products. Prepare herbal packs and herbal soaps by using my formula and prepare and evaluate of herbal hair pack and soap. These are my final products. In first one, I cannot use soap base. In second one, I use soap base. This is herbal hair pack. These are organoleptic evaluation for my herbal hair pack and parameters and results. These are stability test and patch test. Because of we can see many products are harmful or swelling, redness, irritation, or we can see. These are the result of my hair pack and soap. We can see future perspective, consumer growing demand in natural products and increase reach into indigenous herbs. There are potential benefits to our skin. आपण आता मार्केटमध्ये बघतोय की आपल्याला जे प्रोडक्ट्स आपण बघतोय ते त्याच्यामध्ये केमिकल टॉक्सिक इन्ग्रेडियंट्स यूज केलेले असतात. त्याच्यामुळे आपल्याला खूप प्रमाणात बॅड साइड इफेक्ट्स आहेत. त्याच्यासाठी मी हे आयुर्वेदिक प्रोडक्ट्स तयार केलेले आहेत आणि ह्याच्यामध्ये अजून आपण एक फायदा बघू शकतो की आपण शेतकऱ्यांना सुद्धा सांगू शकतो की ह्याचे प्लांटेशन करण्यासाठी किंवा कारण आपण बघतोय कॉस्मेटिक्स इंडस्ट्रीमध्ये खूप प्रमाणात त्याची डिमांड आहे. पण आता आपल्या जनरल गावांमध्ये अजून एवढी त्याची ग्रोथ झालेली नाही. आपण जे जनरल पिकं घेतोय त्याच्यामध्ये आपण जर वेगळी पिके घेतली आणि अजून मार्केट डिमांड काय आहे त्यानुसार जर त्याची ग्रोथ केली तर त्याचा आपल्याला फायदा होऊ शकतो. आणि याचाच आपल्या नॅचरल जे नेचर आहे त्याच्यावर पण बॅड इम्पॅक्ट होतोय. IC-IAS आणि मी MSME थ्रू माझं रजिस्टर एक छोटंसं स्टार्टअप रजिस्टर केलेलं आहे. आणि याच्या थ्रू आपण एक छोटासा नॉट ओनली मी बट ऑल्सो यू कॅन स्टार्ट दिस स्मॉल स्टार्टअप. Those plants use. Yes. म्हणजे मी स्वतः ते कलेक्ट करून त्याची पावडर बनवून किंवा जे फक्त ऑइल वगैरे करू शकत नाही कोल्ड प्रेस ऑइल वगैरे ते फक्त मी मार्केटमधून घेऊन बाकीचे सगळे मी स्वतः प्रिपेअर केले आणि जे नॅचरल आहे ते पूर्ण ॲज युज्युअल यूज केलंय. कारण मार्केटमध्ये आपण बघतोय हे इन्ग्रेडियंट्स यूज केलेले आहेत. थोडेफार गुगलवरचे आहेत आणि थोडेफार मी जे केलेले आहेत ते. हा माझा प्रोजेक्ट वर्क सुद्धा आहे MSc फर्स्ट इयर पासून. हां ॲक्च्युली मोबाईलमध्ये त्याच्यामध्ये मी इन्क्लूड केलेले नाही आहेत. दाखवू शकते मी, आत्ता अवेलेबल आहेत. आणि जो फर्स्ट वन आहे त्याच्यामध्ये मी सोप बेस यूज केलेला नाही आहे. जे सेकंड आहे त्याच्यामध्ये सोप बेस यूज केलेला आहे. हां ते फॉर्म्युले मी सांगितलं ना, जे फॉर्म्युले आहेत ते तयार केलेले आहेत त्यानुसार आपण त्याचं पर्सेंटेज घेऊन ते प्रोडक्ट तयार करतो. जे सोप आहे ते जो फर्स्ट वन आहे तो ॲज अ स्क्रब यूज करू शकतो आपण. हां ते मी स्वतः केलेत. हां टाकलेत फोटो मी. हां जो फर्स्ट वन आहे ना तो चेहऱ्याचा, तो फक्त गुगलवरून घेतलेला आहे. तो बाकीचे जे सोप आहेत ते मी स्वतः काढलेले आहेत फोटो. आणि जे हेअर पॅक वगैरे बिफोर अँड आफ्टरचे ते पण सुद्धा कॉलेजमध्येच केलेलं आहे मी सगळं. कशासाठी? माझं लायसन झालंय ना MSME थ्रू, म्हणजे महाराष्ट्र गव्हर्नमेंट आपल्याला एक स्टार्टअपसाठी एक लायसन देतं. त्याच्यामध्ये माझं रजिस्टर ऑलरेडी गेल्या वर्षीच झालंय. आणि IC-IAS मध्ये एक इन्क्युबेशन सेंटर आहे, त्याच्यामध्ये सुद्धा मी रजिस्टर केलंय. हां 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 जो सोप बेस आहे ना आपण तो यूज केलेला आहे. त्याच्यामध्ये थोड्या प्रमाणात फोम येतोय. आणि जो विदाऊट सोप बेस मी तुम्हाला म्हणलं की मी सोप बेस यूज केलेला नाहीये, त्याच्यामध्ये आपण रिठा यूज केलेला आहे आणि डाळींचे वगैरे पीठ यूज केलेलं आहे. त्याच्यामुळे जास्त प्रमाणात नाही, जास्त प्रमाणात फोम कशामुळे येतो तर केमिकल्समुळे येतो. आणि आपलं एमच हे आहे की केमिकल यूज करायचे नाहीयेत. हां नाही, केमिकल आपण केमिकल यूज नंतर नका करणार ना. हां काय? तो स्क्रब आहे, स्क्रब सोप आहे. नाही, केमिकल यूज केलेले नाही आहेत त्याच्यामध्ये. हां म्हणजे हां हेअर पॅकसाठी बोलताय का तुम्ही? नाही, त्याच्यामध्ये शॅम्पू आपण यूज केलेला नाहीये. त्याच्यामध्ये रिठा आणि शिकक आहे, फक्त एवढंच इन्ग्रेडियंटची पावडर यूज केलेली आहे धुण्यासाठी, ते केस धुण्यासाठी. शॅम्पूमध्ये ऑलरेडी केमिकल्स असतात आणि आपण हेअर पॅक यूज केल्यानंतर आपण केमिकल्स कशासाठी? आणि याचा इम्पॅक्ट पण चांगला आहे, सिल्की केस होतात. आणि आपला जो डॅन्ड्रफसाठी आपण यूज करू शकतो, अँटी डॅन्ड्रफसाठी. आणि शॅम्पू सुद्धा अजून माझा आता शॅम्पूवर सुद्धा एक चाललंय. ॲक्च्युली नलवडे सर. येस येस थँक्यू.
हॅलो, गुड आफ्टरनून ऑल. मी डॉक्टर ताटे सर आणि माननीय संग्राम नलावडे सर यांना विनंती करते त्यांनी स्टेजवर उपस्थित राहावे. A brief introduction to Nalaude sir, who serve as the referee for today's paper presentation. Honorable Sri Sangram Suresh Nalaude sir is currently working as the head of the mathematics department and assistant professor at Yashwantrao Chavan Institute of Science, Satara. He has more than 5 years of teaching experience. His PhD Geometric Function Theory research paper is in progress. He has handled many important responsibilities in academic work. He has guided as a resource person 10 times, also 5 research articles published, 5 articles presented and 4 books published. थँक्यू. मी ताटे सरांना विनंती करते की त्यांनी नलावडे सरांचे गुच्छ देऊन स्वागत करावे. आजच्या पेपर प्रेझेंटेशनसाठी 3 पार्टिसिपेट झालेले आहेत. त्यांची नावं सांगते एकदा. बर्गे दीक्षा, अवळे ऋतुजा, अमंदे संतोष यांनी पुढे यावे.
हाँ, good morning everyone. My name is Diksha Barge and my paper name is Recommendation System of Health Insurance Policy under guidance of Mr. R.S. More sir. तर या पेपरमध्ये आम्ही फजी बेस्ड मॉडेल बनवलेलं आहे जे की रिकमेंड करतं आपल्याला बेस्ट हेल्थ इन्शुरन्स पॉलिसी. तर आपण जे इथे कव्हरेज आणि एज घेतलेलं आहे ते फिक्स्ड घेतलेलं आहे. कव्हरेज जे घेतलेले आहे ते 50 लाख घेतलेलं आहे आणि एज जे घेतलेलं आहे ते आपण 25 इयर्स घेतलेलं आहे. मग त्याच्यामध्ये आपण काय केलं आहे की थोडं खाली घेता का, स्क्रोल करा. त्याच्यामध्ये आपण 7 हेल्थ इन्शुरन्स पॉलिसी कन्सिडर केलेल्या आहेत आणि त्या कशावरून केलेल्या आहेत तर आम्ही गुगलवर रेटिंग्स बघितले आणि त्याच्यामध्ये ज्या 7 आम्हाला बेस्ट वाटल्या म्हणजे आत्ता सध्या लोक जास्त घेत आहेत हेल्थ इन्शुरन्स पॉलिसीज त्या आम्ही तिथे घेतलेल्या आहेत आणि 5 फॅक्टर्स कन्सिडर केलेले आहेत. तसे तर बरेच फॅक्टर्स असतात पण आम्ही त्याच्यातले जे मेन फॅक्टर्स आम्हाला वाटले ते घेतलेले आहेत. तर त्याच्यामध्ये मग आम्ही स्क्रोल करा ना खाली. बरं ठीक आहे, टेबल बनवलेला आहे त्याच्यामध्ये मग पहिल्यांदा आम्ही जे घेतलेलं आहे त्याच्यामध्ये फॅक्टर्स जे आहेत ते आहे क्लेम सेटलमेंट रेशो. आता क्लेम सेटलमेंट मी शॉर्टमध्ये सांगते की क्लेम सेटलमेंट रेशो म्हणजे काय असतं की एखाद्या इन्शुरन्स पॉलिसीने वर्षभरामध्ये किती क्लेम सेटल केलेले आहेत त्याच्यावरून तो रेशो काढला असतो. आणि सॉल्व्हन्सी रेशो त्याच्यानंतर दुसरा फॅक्टर आहे. तर सॉल्व्हन्सी रेशो असा असतो की सॉल्व्हन्सी रेशो म्हणजे एखाद्या हेल्थ इन्शुरन्स पॉलिसीमध्ये तेवढी अबिलिटी आहे का की ते समजा एखाद्या वेळी अशी सिच्युएशन आली की सगळ्या पॉलिसीज त्यांना क्लेम करायला लागल्या, सेटल कराव्या लागल्या, तर मग त्यावेळेला ते करू शकतात का, ही अबिलिटी त्यांच्यामध्ये आहे का, तो सॉल्व्हन्सी रेशो असतो. त्यानंतर आम्ही मंथली इन्स्टॉलमेंट घेतलेली आहे त्याच्यामध्ये कारण ती इम्पॉर्टंट आहे. काही जणांना मंथली इन्स्टॉलमेंट ही खूप जास्त भरता येत नाही, काही म्हणजे प्रत्येकावर डिपेंड असतं ते, त्यामुळे मंथली इन्स्टॉलमेंट एक कन्सिडर केलेली आहे. आणि कस्टमर रेटिंग कन्सिडर केलेली आहे. आणि नेटवर्क हॉस्पिटल, कारण जर आपण हेल्थ इन्शुरन्स पॉलिसी घेतल्याने जर का कडेला आपल्या जे पण हॉस्पिटल्स आहेत तिथे अवेलेबलच नसेल हेल्थ इन्शुरन्स पॉलिसी क्लेम करणं किंवा काय, तर मग आपलं घेऊन काय फायदा. हां, मग ठीक आहे. मग त्याच्यानंतर आम्ही काय केलेलं आहे की ते जे सगळे फॅक्टर्स होते ते वेगवेगळ्या मेजर्समध्ये होते. मग आम्ही एक फॉर्म्युला क्रिएट केला जो की फजी बेस आहे. मग त्या फॉर्म्युलावरून कॅल्क्युलेशन करून आम्ही ते सगळे जे फॅक्टर्स आहेत ते 0 to 1 मध्ये आणलेले आहेत. मग ते आपण कॅल्क्युलेशन वाईज पण करू शकतो, पण कॅल्क्युलेशनला वेळ जातो म्हणून आम्ही तिथे मॅटलॅब कोड वापरला आणि ते सगळे 0 to 1 मध्ये कॅल्क्युलेट केले. आणि मग त्यानंतर 0 to 1 मध्ये केल्यानंतर आम्ही त्या प्रत्येक सेपरेट इंडिव्हिज्युअल इन्शुरन्स पॉलिसीसाठी प्रत्येक सगळे फॅक्टर्स कन्सिडर करून त्याचा ॲव्हरेज काढला. आणि मग तो ॲव्हरेज ज्या इन्शुरन्स पॉलिसीसाठी जास्त येईल ती इन्शुरन्स पॉलिसी बेस्ट इन्शुरन्स पॉलिसी आहे असं आपण फायनल रिझल्ट काढलेला आहे. तर रिझल्टवरून म्हणजे जे काही आपण कॅल्क्युलेशन केलं त्याच्यावरून स्टार हेल्थ इन्शुरन्स पॉलिसी ही बेस्ट आलेली आहे. कारण सर क्रिस्प मॉडेल हे येस नो मध्ये आन्सर देतं, 0 किंवा 1 मध्ये आन्सर देतो. पण असं प्रत्येक गोष्ट आपण म्हणलं जसं की सर्टन नसते, अनसर्टन असतात. मग त्याच्यामुळे फजी जे आहे ते आपल्याला काय म्हणू शकतो आपण की मेंबरशिप व्हॅल्यूज देतात ना, त्याच्यामुळे मग आपण 0 to 1 मध्ये असं व्हॅल्यू म्हणून फजी कन्सिडर केलेलं आहे. थँक्यू.
Greetings of the day to everyone present over here. I am Khushbu Oswal from Tulsaram Chaturchand College of Arts, Science and Commerce, Baramati. My project is, I am a PG student from zoology. My project is synthesis and characterization of silk fibrin nanoparticles and its wound healing applications for medicated fabrics. So firstly, we all know what silk is, and we know the applications of silk in various fields, mainly in clothing industry. But silk is made up of 2 proteins, which is silk fibroin and silk sericin. My project revolves around silk fibroin protein. So what is the structure of silk fibroin protein? When we consider an entire silk thread, these are the fibroin proteins, and this coating is made up of sericin protein. This is the protein structure of silk fibroin. My research hypothesis is I have to prove that silk fibroin nanoparticles are biocompatible and multifunctional polymer. This is the objective. First is that synthesis, characterization, application, and to prove its wound healing properties. This is the methodology. To rapidly recall it, silk cocoons were taken. They were converted into silk threads. Its dissolution was done in calcium chloride and a silk solution was prepared. This silk solution was stylized and its centrifugation was done. After nanoprecipitation, we got the silk fibroin nanoparticles. Now I will say that whatever I have synthesized is silk fibroin nanoparticles, but where is the proof? So we did the characterization of it. So the first characterization technique was FESIM. In FESIM, we did the, with the help of the electron microscopy, we understood the particle size which was between 50 to 150 nanometers. Then we did FTIR, that is the functional group analysis, through which we say that whatever we have synthesized is nothing but the fibroin protein only. After that, we did the biuret reagent test. Biuret reagent is the reagent in which the protein has a peptide bonds in it. This biuret reagent, it reacts with the peptide bond and leaves purple color. Through that, we can conclude that whatever we have synthesized is nothing but silk fibroin nanoparticles. This is the UV-Vis. This is XRD. The average size that we found was 231 nanometers. This is the EDS, that is elemental analysis, and we mainly found nitrogen, carbon and oxygen content, which is the core base of the protein. We all know that. After that, we estimated the blood clotting property. So if we use silk fibroin nanoparticles in for wound treatment, so it clots the blood fast. This is the graph, this is the table, and this is the graph for the table. This was done on various concentrations, and if we see, as the concentration increases, the time required for wound healing decreases. So wound healing is done very effectively and with a fast rate compared to the control. Control nearly requires mean average that is of 10 minutes. But if we see the 0.5 concentration, it requires half of it. So the wound healing is fast and efficient. So then we thought that we can use it for the production of medicated fabrics, which is bandages, sanitary napkins, or maybe gauzes, which will be effectively used for wound treatment, and wound treatment will be done fast and effectively. This is the conclusion of whatever I just told now. And these are the future aspects. These are the references. Thank you so much. Questions? Okay, so there are various parameters for that, but we first thought that what is easily available for us. So the region I belong to, Baramati, around that region, Bombex mori is cultured at a very common rate. So that was easy for us to get. Yes. Silk properties are same, protein is same, sericin is same, nothing difference. Thank you. And I would like to apologize for whatever mess just happened now, for consuming a lot of time. So sorry, and thank you so much.
Myself Santosh Amande, and my paper title name is Digital Root of Product of Consecutive Prime Pairs under the guidance of S. Ritige ma'am, R.S. More sir. Actually, number of prime numbers मी इथे कलेक्ट केलेले आहेत 1 to 1000 आणि त्याच्या पुढे जाऊन 3000 पर्यंत. जर थोडंच खाली घ्या. आणि प्राईम नंबरचं डिजिटल रूट या कन्सेप्टची डिजिटल रूट याने एनी नंबर कॅन बी मॅपिंग टू 1 to 9. If the numbers from for example 147, then digit sum is 1 plus 4 plus 7 means 12, then again 1 plus 2 3. So 147 can be mapping to 3. Every number can be mapping to 1 to 9. That concept is called as a digital root. So I study prime numbers and जर थोडं खाली घ्या 1 to 1000 prime numbers अजून खाली घ्या. Digital root of any prime number is always 1 2 4 5 7 8. 3 6 9 हे कधी डिजिटल रूट येत नाही, कारण जर 3 6 9 डिजिटल रूट आलं तर तो डिव्हिजिबल बाय 3 किंवा डिव्हिजिबल बाय 9 होऊ शकतो. देअरफॉर प्राईम नंबरचं डिजिटल रूट हे नेहमी 1 2 4 5 7 8 येत आहे. त्यानंतर मी ट्विन प्राईमच्या पेअर्स कलेक्ट केल्यात. ट्विन प्राईमचं ज्या वेळेला प्रोडक्ट करतो त्यावेळेला ऑलवेज प्राईम नंबर जे काही डिजिटल रूट येत आहे ते 8 येत आहे. फॉर एक्झाम्पल इथे 11 into 3 केलं, 11 into 13 केलं तर 143 येईल, आणि 1 plus 4 plus 3 केलं तर ते 8 येईल. अजून पुढे जाऊया. त्यानंतर कझिन प्राईम, इफ द डिफरन्स बिटवीन द टू कॉन्सिक्युटिव्ह प्राईम इज 4, देन दॅट पेअर इज कॉल्ड ॲज अ कझिन प्राईम. आणि कझिन प्राईमचं जर आपण प्रोडक्ट करून त्याचं जर डिजिटल रूट घेतलं तर ते ऑलवेज 5 येतं आहे. फॉर एक्झाम्पल 11 into 7 जर केलं तर 77 येतं आहे, आणि 77चं जर डिजिटल रूट घेतलं तर 7 plus 7 14 येतं आहे. सो 14 प्लस म्हणजेच 1 plus 4 अगेन 5 येतं. बघा तिथे डिजिटल रूट 5 दिलेलं आहे. त्यानंतर सेक्सी प्राईम 6 डिफरन्स प्राईम, ज्याला कॉन्सिक्युटिव्ह प्राईममध्ये जर 6 डिफरन्स असेल तर त्याला आपण सेक्सी प्राईम डिफाईन करतो. आणि त्याच्यामध्ये जर डिजिटल रूट घेतलं तर ते व्हॅरी होतं. तिथं मात्र जेव्हा जेव्हा डिफरन्स मल्टिपल ऑफ 6 असेल, म्हणजे 6 असेल, 12 असेल, 18 असेल, तर त्यावेळेला डिजिटल रूट हे व्हॅरी होत आहे 1, 4 और 7. तिथं आपण एक्झॅक्ट सांगू शकत नाही की डिजिटल रूट काय होतं. मग त्यानंतर मी 2, 4, 6च्या पुढे कंटिन्युअसली डिफरन्स 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28 असे पुढे करत गेल्यानंतर तिकडे डिजिटल रूटचा जो लास्ट कॉलम दिसतो त्याच्यामध्ये एक पॅटर्न क्रिएट होतोय. ज्या वेळेला डिफरन्स 2, 4 येतोय, त्या 2 डिफरन्स असेल त्यावेळेला डिजिटल रूट 8 आहे. 4 डिफरन्सच्या वेळेला डिजिटल रूट 5 आहे. 6 डिफरन्सच्या वेळेला तो जो मी वेगळ्या कलरनं दाखवला तो तिथं व्हॅरी होतोय 1, 4, 7ला. सिमिलरली 8च्या वेळेला परत डिजिटल रूट 2 आहे आणि 10च्या वेळी पण डिजिटल रूट 2 आहे. पुन्हा तो 6चं मल्टिपल 12 आल्यामुळे पुन्हा डिजिटल रूट व्हॅरी झालेला आहे आणि पुन्हा 8, 5 व्हॅरी आणि परत 2, 2 दिसतोय बघा. म्हणजे ह्या प्रकारे तो पॅटर्न लाईज झालेला आहे. जरा थोडंसं खाली घ्या. फायनली याचं कन्क्लुजन काढल्यानंतर शेवटी मी जो टेबल दिला त्याच्यामध्ये एक रेकरन्स रिलेशन दिलं आहे. जिथे A1 = 2 असेल तर A1 + 14, एक मिनिट, A1 + 14, if n is a even, then digital root is 8. And A1 + 4, where n is a odd, then digital root is also 8. आणि दुसरं रिलेशन क्रिएट होत आहे A1 = 4 न स्टार्ट केलं तर an - 1 याचे नाही, हे म्हणजे ऑब्झर्वेशननं क्रिएट केलं. हां, प्रूफ नाही केलेलं आहे. हां, 3000 ॲक्च्युली मोर दॅन 3000, म्हणजे काही नंबर्स त्याच्या पुढचे पण आहेत. 4, 5, 7, 7, 9, 4. याचे ॲप्लिकेशन अजून तरी नाही, बट आय विल ट्राय टू इन क्रिप्टोग्राफी, बिकॉज प्राईम नंबरचा जास्तीत जास्त वापर क्रिप्टोग्राफीमध्ये होतोय. थँक्यू.
Good afternoon, everyone. My name is Rutuja Sandesh Avade. I am the student of MSc second year Mathematics. So the topic of my research paper is root assistant using MATLAB software. तर ह्यात आम्ही काय केलेलं आहे, आम्ही एक रूट असिस्टंट फाइंड केलेला आहे जो आपल्याला शॉर्टेस्ट रूट फाइंड करून देतो. ह्यात आम्ही ऑप्टिमायझेशन टेक्निकचा यूज केलेला आहे. त्यातीलही पर्टिक्युलरली ब्रूट फोर्स मेथड ही आम्ही अप्लाय केलेली आहे. ब्रूट फोर्स मेथड ही अशी आहे की ती 100% एक्झॅक्ट आपल्याला सोल्युशन देते. त्यातून आम्ही काय केलं, पहिल्यांदा तर आम्ही एक एक्झाम्पल घेतलं. सर जरा खाली घेताय का, की समजा एखादा जर प्राणी आजारी पडला तर त्याला चेक करण्यासाठी डॉक्टर त्याच्याजवळ येतात, पण एका दिवशी एकच पेशंट असेल असं काही नाहीये ना. मग त्याला समजा डॉक्टर वेटरनरियन असेल, त्याला जर समजा 10 पेशंट चेक करायचे असतील तर त्याला असं डिसाईड करावे लागेल की पहिला कोणत्या पेशंटकडे जायचं, दुसरं कोणत्या पेशंटकडे जायचं. तसं आम्ही एक कोड तयार केला मॅटलॅब सॉफ्टवेअरचा यूज करून. त्या कोडमध्ये त्याने गावाची नावं टाकली की आपला कोड त्याला शॉर्टेस्ट रूट फाइंड करून देतो, जेणेकरून त्याचा वेळही वाचेल, त्याचं अंतरही कमी होईल आणि कमीत कमी वेळात तो पेशंटपर्यंत पोहोचू शकेल. ह्याचे ॲप्लिकेशन भरपूर ठिकाणी आपल्याला पाहायला मिळतील. आपण गुगल मॅप्स बघतो, पण गुगल मॅप्समध्ये कसं आपण स्वतः डेस्टिनेशन ठरवतो की आम्हाला ह्या ठिकाणाहून दुसऱ्या ठिकाणापर्यंत जायचं आहे, मग ते आपल्याला रूट फाइंड करून देतं. ह्या कोडचा यूज केल्यानंतर कोड आपल्याला फाइंड करून देणार की तुम्ही पहिल्यांदा कोणत्या ठिकाणी गेलं पाहिजे, दुसऱ्यांदा कोणत्या ठिकाणी गेलं पाहिजे, जेणेकरून तुमचा वेळही वाचेल आणि डिस्टन्सही कमी होईल. समजा आपण जर एखादी ट्रिप प्लॅन करणार असू किंवा समजा इलेक्शन चालू आहेत आणि इलेक्शनच्या टाइमला पॉलिटिशियनला लोकसभा वगैरे घ्यायच्या आहेत, तर त्यासाठी त्यांना यूज होईल ह्या गोष्टीचा. त्यांनी अगदी कोणतीही विलेजेसची नावं वगैरे टाकली की त्यांना अगदी कमी सेकंदामध्ये त्याचं उत्तर मिळून जाईल. खाली दिलेला आहे कवठे, सुरूर, चांदक, केंजाळे आणि पांडे. तर तो आपला ऑप्टिमल रूट आलेला आहे, ज्याचं आम्ही व्हेरीफाय केलं हे मॅटलॅबच्या साह्याने ब्रूट फोर्स मेथडमध्ये सगळे ऑल पॉसिबल रूट्स आहेत ना ते आधी कॅल्क्युलेट करावे लागतात. मग ते टाइम कन्झ्युमिंग आहे. मग हे कोड आपल्याला अगदी सेकंदमध्ये उत्तर घ्यायचे म्हणजे नाही, म्हणजे मॅथमॅटिकल मॉडेल आम्ही नाही यूज केलं कोणतं.
यानंतर भूगोल विषयाचं रिसर्च पेपर प्रेझेंटेशन होईल. यासाठी रेफरी म्हणून भूगोल विभाग प्रमुख व किसनवीर महाविद्यालयाचे उपप्राचार्य प्रोफेसर डॉक्टर विनोदवीर सर आहेत. तर पहिली विद्यार्थिनी जी आहे ती साक्षी शिवाजी डेरे, तिनं यावं आणि प्रेझेंटेशन करावं.
Good morning, everyone. My name is, good afternoon, everyone. My name is Sakshi Shivaji Dere. I'm third year student of BCA. I have done certification course in GIS, so I have prepared a research paper on assessment of vegetation loss due to highway construction along NH4 from Pune to Satara corridor from 2011 to 2025 using GIS. So introduction, in rural infrastructure development play vital role in our religion development. So however it leads to deforestation, habitat loss and ecological imbalance. So in study area we add location map of from Pune to Satara and add a buffer of 500 meters along with both sides. Objective to assess vegetation changes using NDVI technique within 500-meter buffer zone along with both side highways. To quantify vegetation loss within 500-meter buffer zone along with highway. This map also find changes between land use and land cover along with NH4 highway. We use list for satellite data to analyze vegetation loss and NH4 highway from Pune to Satara, which we digitize and use GIS software to analyze vegetation loss. We use methodology flowchart. First we collect satellite data, then image processing, and then we done highway digitization. After that we apply buffer creation along with both sides of 500 meters. Then we put it NDVI formula to our satellite images. Then we classify our data into land use land classification and classify data into four classes. Then we find out change detection, analysis, and after result interpretation will be displayed. Firstly, we digitize Pune to Satara highway along with 500-meter buffer. After that, this is the map of and land use land cover changes from 2011 to 2025. In first image, it displays that green color displays high vegetation, means dense vegetation, which displays mango trees, peepal trees, and big trees. But faint green displays sparse vegetation, and red color displays build up and infrastructure construction sites, and blue color is used to represent water. So it displays. It is not shown very well in one image, so we put it in smaller parts. It shows red color shows build up, and so it displays that in 2011 there was less build up, and after in 2025 there is growth in build up and road construction. Expand highway leads to decreases dense vegetation. It displays that a reduction in dense vegetation means so many trees cut it down, and it overall in fact. तर हे दाखवतं की जेव्हा रोड बनला गेला त्यावेळेस खूप झाडं तोडली गेली, आणि याचा इम्पॅक्ट हायवेच्या दोन्ही पण साईडला झाला आहे. म्हणजे तिथे हॉटेल वगैरे बांधली गेली, आणि तिथला इकॉलॉजिकल बॅलन्स बिघडला आहे, आणि तिथली झाडे पण कट केलेली आहेत. थँक्यू. हो.
Good afternoon everyone, my name is Supriya Namde Patne. I am currently BCA third year. My research paper name is Spatial Analysis of Crop Concentration Patterns in Satara district in Maharashtra. तर मी सोशो इकॉनॉमिक abstract मधून 2024-25चा क्रॉप कॉन्सन्ट्रेशनचा डेटा सिलेक्ट करून तो एक्सेलमध्ये तालुका वाईज सोशो इकॉनॉमिक्स अबस्ट्रॅक्टमधून 2024-25चा क्रॉप कॉन्सन्ट्रेशनचा डेटा सिलेक्ट करून तो एक्सेलमध्ये तालुका वाईज त्याचा डेटा पेस्ट केला, आणि त्याच्यानंतर GISमध्ये सातारा डिस्ट्रिक्टची झिप फाईल त्याला जॉईन करून भाटियाचा क्रॉप कॉन्सन्ट्रेशनचा फॉर्म्युला यूज करून त्या एक्सेलचा टेबल कॅल्क्युलेट करून मॅप तयार केले. आणि ऑब्जेक्टिव्हमध्ये आपल्याला म्हणजे तालुका वाईज ज्या तालुक्यामध्ये जास्त प्रमाणात जास्त प्रमाणात कोणती पिके जास्त प्रमाणात घेतली जातात हे पाहायला मिळतं. आणि हे एरिया स्टडी आहे, याच्यामध्ये 11 तालुके पाहायला मिळतात. आणि ही मेथडॉलॉजी आहे, मी जो एक्सेलमध्ये डेटा जॉईन केला होता तो त्याचे वेगवेगळे मॅप तयार करून भाटियाचा फॉर्म्युला यूज केला आणि त्याच्यानंतर क्रॉप कॉन्सन्ट्रेशनचे हे एक इंडेक्स तयार केली की 2पेक्षा जास्त, 1 आणि 2पेक्षा जास्त आणि 1. आणि हा मी कॅल्क्युलेट केलेला डेटा एक्सेलमध्ये डेटा कॅल्क्युलेट केलेला आहे. आणि हा ग्रेन कॉन्सन्ट्रेशन आहे. ग्रीनमध्ये दिसतंय ते हाय कॉन्सन्ट्रेशन आहे आणि ब्ल्यूमध्ये दिसतंय ते लो कॉन्सन्ट्रेशन आहे आणि ऑरेंजमध्ये दिसतंय ते मीडियम कॉन्सन्ट्रेशन आहे. आणि कंक्लुजन की हेच की आपण सातारा जिल्ह्याचे जे क्रॉप कॉन्सन्ट्रेशन हे सतत बदलत असते, अकॉर्डिंग टू जिओग्राफिकल डायव्हर्सिटी. थँक्यू.
लोकांच्यावरती पीएचडी करतात, तुम्हाला माहित नाही म्हणून तसं करतात.
Good afternoon, everyone. My name is Samruddhi Sharat Kamre. I am currently studying BCA third year in Kisanvir Mahavidyalaya WAI. I have prepared research paper on changing cropping pattern in Khandala and Fulton Tehsil 1991 to 2025, a comparative analysis. I have prepared research paper. I have done certificate course in GIS. Introduction. तर objective to examine temporal changes in major crop categories from 1991 and 2025. म्हणजे 1991 ते 2025 मध्ये मेजर एक्झामिन टेम्पोरल चेंजेस मेजर क्रॉपमध्ये कसे कॅटेगरीज केले गेले ते आपण ह्यामध्ये दाखवलेलं आहे. आणि मेथडॉलॉजीमध्ये म्हणजे कार्यपद्धती हा स्टडी आपण 1991, 2001, 2011, 2021 आणि 2025 या सालाचा इरिगेशन कार्यपद्धतीवर केलेला आहे. म्हणजे धोम धरणाचा धोम बलकवडी कॅनल हा फलटणपर्यंत खंडाळापर्यंत जाऊन जो आपली इरिगेशन शेतीची कृषी क्षेत्राची आपली जी बदल झालेला आहे हा प्रोजेक्टमध्ये दाखवला आहे. स्टडी एरिया ह्यामध्ये आपण खंडाळा आणि फलटण या 2 तहसीलचा स्टडी डिजिटायझेशन केलेला आहे. क्रॉपिंग पॅटर्न अँड चेंजेस इन खंडाळा म्हणजे राईस म्हणजे प्रत्येक पिकं खंडाळ्याची प्रत्येक सालाची कशी कशी त्यांची वाढ होत गेलेली हे दाखवलेलं आहे. हे क्रॉपिंग पॅटर्न फलटणचे तेही पिकांची वाढ कशी होत गेली ते दाखवलेले आहे. यावरून आपल्याला समजणार की फलटणमध्ये शेतीची विविधीकरणामध्ये झाल्याचे बदल दिसून येत आहेत. फ्रॉम कमर्शियल ॲग्रिकल्चर म्हणजे त्यात डिक्लाइन अँड सोरगम्स म्हणजे इन्क्रीज इन सोयाबीन्स, ग्रोथ इन फ्रूट अँड व्हेजिटेबल, एक्सपान्शन इन नॉन एडिबल क्रॉप्स, फलटण ट्रान्सफॉर्मेशन इज फास्टर अँड मोर इन्सेन्सिटिव्ह. कन्क्लुजन यामध्ये 1991 ते 2025 दरम्यान खंडाळा व फलटण तालुक्यामध्ये पीक पद्धतीतील लक्षणीय बदल झालेला आहे. पारंपरिक तृणधान्य विशेष म्हणजे ज्वारीचे वर्चस्व मोठ्या प्रमाणात झालेले दिसून येत आहे. व्यापारी पिके, सोयाबीन, बागायती पिके या पिकांमध्ये फलटण तालुक्यातील मोठ्या प्रमाणात वाढ झालेली आहे. फलटण तालुका खंडाळ्याच्या तुलनेने अधिक वेगाने आणि तीव्रतेने कृषी पुनर्रचना अनुभवत आहे. आकडेवारीतून निर्वाहीधारित शेतीतून बाजारभिमुख विविधकृत शेतीकडे स्पष्ट संक्रमण दिसून येते. आउटकम्स, पॉझिटिव्ह आउटकम्स म्हणजे सकारात्मक परिणाम. शेतकऱ्यांचे उत्पन्नाची वाढ होताना दिसून आलेली आहे. रोजगारांची निर्मिती म्हणजे जर शेतीमध्ये जर आपल्याला आपलं रोजगार आपण करू शकतो. कृषी आधारित उद्योगांची वाढ म्हणजे कृषीमध्ये जर आपल्याला इन्क्रीजिंग झालं तर आपल्याला त्यांच्यात वाढ होताना दिसून येते. ग्रामीण पायाभूत सुविधांची विकास झालेला आहे. आणि कॉन्सर्न्स म्हणजे चिंता, स्थानिक अन्नधान्य उत्पादनातील घट, अतिव्यावसायिकरणाचा धोका, बाजारभावातील चढउतारांमुळे अस्थिरता आणि अर्धशुक्ल हवामानात टिकाऊपणाचे प्रश्न. थँक्यू.
Good afternoon, everyone. Myself, Sanika Sachin Goye. I am from BCA 3rd. I have done certificate course in GIS. I have prepared research on spatio-temporal analysis of government health infrastructure in Satara district. Me, sorry. Objectives. The main objective of study are to analyze taluka-wise population growth from 1991 to 2021, to examine the temporal growth of government hospital and primary healthcare center, to calculate hospital population ratio for different census years, to categorize taluka into high, medium and low healthcare service levels. Data sources, methodology. मी हा डेटा पॉप्युलेशन आणि हॉस्पिटलचा कंबाईन केला आहे आणि नंतर हॉस्पिटल आणि पॉप्युलेशनचा रेशो कॅल्क्युलेट केला आहे युझिंग फॉर्म्युला. नंतर मी टेब्युलर डेटा आणि तालुक्याची शेप फाईल ती कनेक्ट केली GIS सॉफ्टवेअरमध्ये आणि नंतर मॅप तयार केले ती इयर वाईज. आणि नंतर तालुक्याचं कॅटेगराईज केलं आहे 3 ह्याच्यामध्ये हाय, मीडियम अँड लो. नंतर मी हा इयर वाईज पॉप्युलेशन आणि हॉस्पिटलचा डेटा गोळा केला आहे. फक्त 2021चा प्रोजेक्टेड डेटा आहे कारण त्यावेळेस कोरोनामुळे जनगणना झाली नव्हती. नंतर 19 पॉप्युलेशन ग्रोथ ट्रेंड्स 1991 अँड आणि 2021मध्ये सातारा, फलटण आणि पाटण आणि कराडमध्ये हायेस्ट लोकसंख्या वाढलेली तेव्हा, आणि हिली तालुकाच महाबळेश्वर आणि जावलीमध्ये कमी झालेली. नंतर 1991मध्ये सगळीच म्हणजे नंबर ऑफ हॉस्पिटल कमीच होती. तिथं मी नंबर ऑफ हॉस्पिटल इंडेक्स केली आहे. जी फेंट ऑरेंज आहे तिथं 0 ते 10पर्यंत हॉस्पिटल होते. नंतर डार्क ऑरेंजमध्ये 10 ते 35 हॉस्पिटल होती. नंतर फेंट ग्रीनमध्ये 35 ते 60 हॉस्पिटल होती आणि डार्क ग्रीनमध्ये 60 ते 85 आणि ब्ल्यूमध्ये 85पेक्षा जास्त. तर 1991मध्ये सगळ्याच तालुक्यांमध्ये हॉस्पिटल कमी होती, हॉस्पिटलची संख्या. नंतर 2001मध्ये जरा मीडियम झाली, 2011मध्ये सुद्धा थोडी मीडियम झाली. नंतर 2021मध्ये सातारा आणि कराडमध्ये जरा वाढली. आणि नंतर हॉस्पिटल पॉप्युलेशन रेशोमध्ये हॉस्पिटल टू पॉप्युलेशनमध्ये महाबळेश्वर आणि जावलीमध्ये जरा हाय झाली. नंतर पाटण, खंडाळा, मान, खटाव, वाई, कोरेगावमध्ये मीडियम आणि कराड, सातारा आणि फलटणमध्ये लो. नंतर कन्क्लुजनमध्ये सातारा डिस्ट्रिक्टमध्ये हॉस्पिटलची लोकसंख्या वाढली, पण तालुका वाईज वाढली. जशी की वाई, जावली आणि महाबळेश्वर वाई, जावली आणि खंडाळामध्ये पॉप्युलेशन नुसार हॉस्पिटलची संख्या कमी झाली आणि बाकीच्या तालुक्यांमध्ये मीडियम राहिली आणि कराड आणि सातारामध्ये वाढली.
Good afternoon, everyone. My name is Pragati Mohan Mandre. I am from BCA last year student. I have done certification course in GIS. I have prepared research on spatio-temporal analysis of literacy rate in Satara district under guidance of Karademis. ऑब्जेक्टिव्हमध्ये मी या प्रेझेंटेशनमध्ये 1961 ते 2011 यामध्ये लिटरसी रेटची कशी ग्रोथ होत गेली त्याच्यावर मी हे प्रेझेंटेशन केलेलं आहे. त्यात त्याचे मेन ऑब्जेक्टिव्ह आहेत की टोटल लिटरसी रेट ॲनालिसिस करणं, मेल फिमेल लिटरसी कम्पेअर करणं, जेंडर गॅप मेजर करणं. हा मी सेकंडरी डेटा मिळवला आहे. 1961 साली आपली लिटरसी ग्रोथ कशी होती की 1961 साली मेल आणि फिमेल टोटल लिटरसी आपली होती की ब्ल्यू कलरमध्ये 20 ते 40% आपली लिटरसी ग्रोथ होती आणि ग्रीन कलर म्हणजे आपला 40 ते 60% आपली लिटरसी ग्रोथ होती. त्यामध्ये आपल्याला सातारा डिस्ट्रिक्टची रेंज ही 42.56% दिसते, तर मानची 21.64% दिसते. ही आहे मेल लिटरसी 1961 सालची. त्यावेळेस मेल लिटरसी सगळ्यात जास्त कराडची होती की 52.4% आणि मानची आहे की 39.8%. त्यावेळेस त्यानंतर ही फिमेलची आहे. त्यावेळेस फिमेल लिटरसी ही सगळ्यात जास्त साताऱ्याची 24.1% आणि मानची 11.4% होती. त्यावेळेस फिमेल लिटरसी आपल्याला खूप कमी प्रमाणात 1961 साली बघायला मिळते. त्यानंतर हे 1991 की आपण ह्या मॅपमध्ये बघितलं तर लिटरसी ग्रोथ ह्यात आपल्याला वाढलेली दिसते. जसं की माणची 54.57% तर साताऱ्याची 74.15%. ही 1991ची मेलची लिटरसी. यामध्ये रेड कलरमध्ये आपल्याला दिसून येतं की लिटरसी ग्रोथ ही 80 ते 90% दिसते. सगळ्यात हायेस्ट लिटरसी ही आपल्या सातारा जिल्ह्याची 84.1%, तर सगळ्यात लो लिटरसी ही माणची 71.4%. मेल लिटरसी क्रॉस 75%, म्हणजे आपल्याला 1961 ते 1991 मध्ये आपली लिटरसीची वाढ झालेली दिसते. तसंच फिमेलमध्ये पण फिमेलची लिटरसी सातारा डिस्ट्रिक्टची 63.8% आणि मान डिस्ट्रिक्टची 37.8% दिसते. आपण जर बघायला गेलं तर फिमेल लिटरसी आणि मेल लिटरसीमध्ये खूप मोठ्या प्रमाणात आपल्याला 1961 मध्ये गॅप दिसला. त्याचबरोबर हा थोडासा कमी झालेला आपल्याला 1991 मध्ये दिसतोय. हा आहे 2011चा लिटरसी डेटा. यामध्ये आपल्याला हायेस्ट लिटरसी ही वाईची दिसते, वाई तालुक्याची 83.15% आणि सगळ्यात कमी लिटरसी ही जावळी तालुक्याची दिसते 76.15%. आपल्याला 2011 मध्ये दिसतंय की लिटरसी ग्रोथ ही जरा वाढलेली दिसते. ऑरेंज कलरमध्ये आपल्याला 80 ते 90% यामध्ये आपल्याला लिटरसी ग्रोथ वाढलेली दिसते आणि पिवळ्या कलरमध्ये आपल्याला 40 ते 60% मध्ये लिटरसी ग्रोथ ही वाढलेली दिसते. त्याचबरोबर ही 2011ची मेल लिटरसी आहे. आपण जर 2011ची मेल लिटरसी बघितली तर आपल्याला पूर्ण कलर हा ऑरेंज कलरमध्ये दिसतोय, म्हणजेच 80% प्लस 80-85% प्लस आपली लिटरसी ग्रोथ ही वाढलेली दिसते. सगळ्यात हाय लिटरसी ही वाईची दिसते 89.85% आणि लोवेस्ट लिटरसी 85.3%. त्याचबरोबर जर आपण फिमेल लिटरसी बघितली 2011ची तर पूर्ण कलर आपल्याला पिवळा दिसतोय. फिमेल लिटरसी आपल्याला 60 ते 80 यामध्ये दिसते, वाढलेली दिसते. तरीही आपल्याला थोडीशी कुठेतरी एक जाणवते की फिमेल आणि मेल यामध्ये थोडासा गॅप जाणवतोय की लिटरसी थोडीशी अजून वाढली पाहिजे. हे कन्क्ल्युजन आहे की अजून आपण काय करायला पाहिजे. आपली 2021ची जनगणना कोविड-19मुळे झाली नाही, त्यामुळे मला तो डेटा मिळाला नाही. कन्क्ल्युजनमध्ये मी सांगते की 1961 ते 2011 मध्ये लिटरसीमध्ये डिस्ट्रिक्ट आहे रिकम्परेबल प्रोग्रेस झाली, जेंडर डिस्पॅरिटी कमी झाली, पण फिमेल लिटरसी आपल्याला कुठेतरी कमी जाणवते. ती इम्प्रूव्ह करणे गरजेचे आहे. त्यासाठी इम्प्रूव्ह करणे गरजेचे आहे. परत बॅलन्स रिजनल डेव्हलपमेंट आणि रुरल एज्युकेशनल स्ट्रेंथ करणे इम्पॉर्टंट आहे. थँक्यू सो मच.
सगळ्यांनी लक्ष द्या, 1-2 मिनिटं. 5 मिनिटांमध्ये व्हॅलिडिटी फंक्शन चालू होईल. चहा घ्यायचा आणि लगेच क्लासरूम मध्ये यायचे.
फीडबॅक फॉर्म भरून द्यायचे लगेच आता. व्हॅलिडिक्टरी फंक्शन सुरू होण्याच्या अगोदर सगळ्यांना विनंती आहे की त्यांनी घेतलेले फीडबॅक फॉर्म हे जमा करायचेत मॅडमच्याकडं. Good evening, everyone. A very warm and respectful welcome to all the dignitaries on the dais, respected resource person, honorable chairperson, delegates, participants, faculty members, students, and all present here. We have now reached the concluding part of this prestigious one-day international conference on interdisciplinary approaches in science, engineering, and technology, jointly organized by Janta Shikshan Sanstha's Kisanveer Mahavidyalay, WAI, and Faculty of Science, Research and Development Cell and IQAC in association with Aerogel Materials Research Center, Yansha University, South Korea. This session is the valedictory function where we shall reflect on the day's valuable learnings, expresses gratitude, and formally conclude the conference. To begin this valedictory function, I would like to invite Professor D.N. Zhamre sir, the convener and head of the department, to welcome and introduce today's conference.
Good evening, distinguished dignitaries, respected delegates, eminent speakers, faculty members, researchers, and dear students. Our distinguished chief guest and respected secretary, Dr. Jayant Chaudhary sir, president of the inaugural function, respected principal Dr. Gurunath Phagre sir, respected Vice Principal Professor Dr. Vinod Veer sir, co-coordinator Dr. Sandeep Wategaonkar sir, IQAC coordinator Dr. Shivaji Kamble, very good evening to all of you. It's gives me immense pleasure and deep sense of honor to welcome you all to the valedictory function of the one-day international conference on interdisciplinary approaches in science, engineering, and technology. This conference has been jointly organized by the Faculty of Science, Research and Development Cell, IQAC of our institution, in the collaboration with the Aerogel Material Research Center, Yonsei University, South Korea, under an academic MOU. Today's conference has been a remarkable platform for intellectual interaction where scholars, scientists, academicians, and students from diverse disciplines came together to deliberate, discussion, disseminate ideas, and transcend traditional academic boundaries. The interdisciplinary approaches emphasis throughout the session has reminded us as that the challenges of the modern world cannot be solved in solution. They require collaboration, integration of knowledge, and spirit of the collective inquiry. Throughout the day, we have witnessed insightful presentation, stimulating discussion, and throughout provoking perspectives shared by our distinguished speakers, along with the excellent oral and poster presentation by participants. Such academic gathering not only enriched our knowledge, but inspire a new research direction, fostering collaboration and nurture young mind to think beyond the conventional limits. On behalf of our organizing committee, I extend my heartfelt gratitude to all the resource persons, delegates, participants, volunteers whose enthusiastic involvement made this conference a grand success. Your presence and contribution have added immense and value prestigious to the academic endeavor. As we move towards the conclusion of the enriching event, let us carry forward insight, inspiration, and collaborative spirit we have gained today. May this conference serve as a stepping stone for future research, partnership, and innovative breakthrough that contribution meaningfully to the science, engineering, technology, and society at large. Thank you all once again for your gracious presence and participation. I wish you a pleasant and safe journey ahead. Thank you.
Thank you, sir, for your warm welcome and for setting the tone of this valedictory session. I would like to request respected principal sir to honor and welcome today's chief guest, Honorable Dr. Jayant Chaudhary, Secretary of Janta Shikshan Samstha, WAI. So as the chief guest of this valedictory function. Thank you, sir. Thank you. I request Professor Dr. D.N. Zamre sir to honor our respected principal, Dr. Gurunath Phagre, the president of this valedictory function. Dr. Gurunath Phagre sir. Thank you, sir. I request Honorable Dr. Jayant Chaudhary sir to honor and welcome the convener of today's international conference, Professor Dr. D.N. Zamre sir. Thank you, sir. Once again, I request Honorable Dr. Jayant Chaudhary sir to honor the co-convener of this workshop, Dr. Vategaonkar sir. Thank you, sir. I would like to request Dr. S.B. Vategaonkar sir to welcome and honor the Vice Principal of our Kishanvir Mahavidyalaya WAI, Professor Veer sir. Thank you. I would like to request Professor D.N. Zamre sir to welcome and honor our principal. Dr. Gurunath Phagre. Thank you, sir. May I now invite Professor Dr. Vinod V. sir to introduce our chief guest.
Good evening. Dignitaries on the dais and off the dais. As we gather for the valedictory section of this international conference, it gives me immense pleasure to introduce a scholar whose academic journey reflects excellence in teaching, research and institutional leadership, Dr. Jayant Chaudhary. Dr. Jayant Chaudhary is a distinguished academician, administrator and educationalist who presently serves as a Secretary of Janta Shikshan Samstha WAI. Within a lifelong commitment of higher education, particularly in the field of commerce and management, he has played transformative role in shaping academic excellence in the WAI region. Dr. Chaudhary began his academic journey as a student of our college and holds the distinction of being a member of first batch of MCOM at our college. His deep association with the institution continued as he joined the Department of Commerce and Management as a lecturer. Through dedication and scholarly excellence, he later became the head of the department, contributing significantly to the academic development and curriculum strengthening. Recognizing his leadership and availability and vision, he was appointed as a principal of our college, where he worked tirelessly to enhance the institutional growth. One of his landmark achievements was the establishment and development of MPhil and PhD research centers in our college, thereby promoting advanced research in commerce and management. A creative writer and scholar, Dr. Chaudhary has authorized a large number of books in field of commerce and management, which have benefited countless students and the researcher. He has successfully guided many scholars for their MPhil and PhD degrees, contributing immensely to the research culture and academic membership. His scholarly contribution extend further as he has also written academic notes and entries for the Marathi Vishwakosh, contributing to the enrichment of the knowledge in the Marathi language. Beyond academics, he has shared his inspiring life journey through his autobiography titled Swapna Palad, reflecting his determination, vision and dedication to the education. Dr. Jayant Chaudhary's life demonstrates commitment to the knowledge, leadership in education and serves as a society through academic excellence. Thank you, sir.
Thank you so much, sir, for your thoughtful introduction. A conference becomes truly successful when participants share their experience and feedback. Now we have the session of the feedback by participants, where participants will share their views, learnings, and overall experience of this international conference. So may I request now Dr. Pratik Sunil Kamble from the LBS College Satara to share his experience on entire conference.
Good evening, everyone. I am Dr. Pratik Kambe, working as assistant professor at LBS College, Satara, Department of Botany. Today, I have presented as a faculty my research work. I would like to say a few words, sir, then I will give the feedback. When I was in BSc, in my bachelor's, I have also presented in conference. When I was in my UG, when I was doing my MSc in Shivaji University, Kolhapur, I have also presented my work in university. Then I have go to my PhD, then I have also presented my work as a research student, and today I have presented secondly as a faculty. I just want to say that this confidence and that confidence is eagerly very different, sir. I am standing here as a student because I respect my research guide, Dr. Swarupa Amit Patil madam, because she gave me that confidence, and now I am standing here because of my guide. So I would like to say to participant that the research is a very big thing, but when you are going to respect your guide, your teacher, then your research is going to be very successful. So I request everyone, when you are going to do any research, when you are going to respect your guide, that research will be going to get fulfilled. So the conference was very delightful, sir. I am thankful to all organizers. The food was very delicious. The proper time management was there, and I am thankful to everyone. Thank you one and all.
Thank you so much, sir, for your valuable feedback. Now I request Khushbu Oswal from TC College, Baramati, to share her experience.
Greetings of the day to everyone present over here. Speaking about research, this is the second year for me in the field of research as a student, of course. One thing that I have learned from my entire journey is when you do research, be shameless, but don't be hopeless. Keep knocking at the doors till one door doesn't open for you and tells you that yes, get in. Till then, keep knocking. I have did the same thing. Speaking about today's conference, this is the platform that gives students like us the proper confidence to be ourselves, to speak what we have done. Doing lab work is okay, but to be able to show the work to the entire world is a different thing. To present it is a different thing. And this is the platform that gives us that daring. So thank you so much for this opportunity. The management was perfect, made be online registrations, the food, the way each and every session was carried out, connecting with someone who is sitting in Japan, and to be able to listen to that person, what he did there, and to get insights of his work, and to inspire ourselves through his work is a different thing. And thank you so much for that. I also thank the entire team for giving this platform. Thank you so much.
Thank you, Khushbu, such a wonderful feedback. Now I invite Santosh Vishwanath Amde, Yashwantrao Chawani Institution of Satara.
Good evening, everyone. My name is Santosh Amande from Yashwantrao Chawani Institute Science, Satara. आता ज्या मॅडमनी सांगितलं की रिसर्च ही अशी बाब आहे की जिथं कधी निराशा घेऊन येऊ नये, तसंच मलाही वाटतं. कारण सुरुवातीला रिसर्च पेपर लिहायसाठी ज्यावेळेला प्रयत्न केला त्यावेळेला एका वेगळ्या अँगलनं रिसर्च पेपर ट्राय करत होतो की प्राईम नंबर्समध्ये काही अरिथमेटिक प्रोग्रेशन मिळेल का, पण तसं काही भेटलं नाही. त्यामुळं 2-3 महिन्यानंतर ते वाया गेलं. पुन्हा 3-4 महिने दुसऱ्या एका याच्यावर काम केलं की एक थेरम तो प्राईम नंबर्सवर प्रूफ होईल का, तर तोही अप्लायड झाला नाही. आणि आत्ता एक 10 दिवसापूर्वी रिसर्च पेपर तर आपल्याला द्यायचा होता. मग आमचे गाईड नेलवडे सर आणि मोरे सर यांनी सांगितलं की थोडंसं वेगळ्या अँगलनं थिंकिंग करून काय जनरलाइज होतंय का प्रयत्न कर. मग त्यानंतर पुन्हा प्रयत्न केला आणि पुढच्या 3-4 दिवसामध्ये जो मी रिसर्च पेपर मगाशी तुम्हाला दाखवला की प्राईम नंबरमध्ये जी प्रॉपर्टी अप्लाय होते डिजिटल रूटवर ती अप्लाय झाली. त्यात मला खूप आनंद झाला की बाबा कुठं ना कुठेतरी एक जो वे घेतला होता त्या अँगलला जरी नाही सक्सेसफुल झालं तरी दुसरा सुद्धा अनसक्सेसफुल झाला, पण तिसरा ट्राय मात्र तिथं माझा सक्सेसफुल झाला. हे एक सांगायचं होतं की रिसर्चमध्ये कधीही निराशा मिळत नाही. काही ना काहीतरी प्रयत्न करत राहिलं तर आपल्याला काही ना काहीतरी त्यामध्ये भेटणार असतं. फक्त आपले प्रयत्न मात्र प्रामाणिक पाहिजेत. आणि इथे खूप उशीर झाला होता माझा पेपर पूर्ण तयार करायला, त्यामुळे PPT नाही बनवू शकलो, पण तरीही PDF असेल तरी चालेल म्हणले. PDF तुम्ही दाखवू शकता आणि PDFवर तुम्ही तुमचा रिसर्च पेपर डिस्प्ले करू शकता, एक्सप्लेन करू शकता. आणि त्यामुळे मला हा डिस्प्ले करता आला, त्यामुळे मॅनेजमेंटचा मी खूप आभारी आहे. आणि इथं जी आम्हाला व्यवस्था किंवा ज्या प्रकारे आम्हाला तुम्ही आमचं म्हणजे अतिथींचं जसं इथं स्वागत केलं जातं आणि ज्याप्रमाणे आम्हाला सर्व्हिस दिली जाते ती खूप छान होती. थँक्यू.
Thank you, sir, for sharing your experience. Now I invite Vijay Shri Hemke, Shri Shivaji Science and Arts College, Chikli, District, Buldhana.
गुड इव्हिनिंग टू एव्हरीवन. आय एम डॉक्टर विजय श्री हेमके. आत्ताच इंट्रोड्यूस केलं आहे. आय एम फ्रॉम शिवाजी कॉलेज चिखली, डिस्ट्रिक्ट बुलढाणा. इट्स माय इमेन्स प्लेजर to participate in this international conference which is organized in collaboration with Yonsei University, South Korea, on interdisciplinary approaches in science, engineering and technology. When I entered in the college, I observed since from registration table everything was excellent and well disciplined. Keynote address of Dr. Sudhir Arbuz sir and Professor Akio Kimura was great, which opens gate of new mindset. अगदी वेगळं असं रिसर्च खरंच पाहायला मिळालं आणि रिसर्च अपडेट्स कुठपर्यंत गेले ती लेवल बघायला मिळाली. त्याची डेप्थ जी होती ती ऑब्झर्व झाली. खूप छान वाटलं. अँड इट वॉज रिअली ग्रेट ब्रेन स्टॉर्मिंग सेशन. I work as a jury for oral and poster presentation and I realize the quality of the research. It is really better from the expectation. And I congratulate to all winners and really appreciate their efforts. And at last, catering, snacks and lunch, high tea was very good. I enjoy it. Hospitality of the college from every person of your team is really appreciable. I congratulate to President of the Honorable President, Honorable President Madan Dada Bosle sir, Secretary Honorable Jayan Chaudhary sir, Principal respected Fagare sir, convener of the conference Dr. Jhamre sir, Dr. Vategavkar sir, co-convener IQ-IASET coordinator and every team member of the conference. कारण सगळ्यांचे जॉईंट एफर्ट्सनी ही कॉन्फरन्स एवढी सक्सेसफुल झाली. आणि ठीक आहे आपण हा फीडबॅक देत असतो, सगळं छान म्हणत असतो, पण रिअली छान होतं. आणि खरंच यातली ॲप्रिसिएबल गोष्ट रिसर्च प्लॅटफॉर्म ही होती की रिअली स्टुडंटनी फिअरलेस प्रेझेंटेशन केले, त्यांच्या मनातलं ते बोलले आणि छान म्हणजे जो त्याचा आउटकम यायला पाहिजे होता त्याच्यामध्ये आपण अगदी सक्सेसफुल झालो. सो आय कॉंग्रॅच्युलेट टू एव्हरीवन अँड थँक्यू अँड आय एम रिअली एन्जॉय द कॉन्फरन्स. दुरून आल्यावरही मला अरे छान झालं आपण आलो असं वाटलं. थँक्यू एव्हरीवन.
Thank you so much, ma'am, for your positive remark. I take the privilege to invite Dr. S.B. Vategavkar sir to present the reports on entire conference.
I know you all are eagerly waiting for your prize, but this is the formality of the program that I will read the today's report. The one-day international conference on interdisciplinary approaches in science, engineering and technology was successfully organized by Science Faculty, Research and Development Cell and Internal Quality Assurance Cell of the Kishanveer Mahavidyalaya with collaboration with Aerogel Material Research Center, Yonsei University, South Korea. The primary objective of this conference was to promote interdisciplinary research integrates across diverse domains of science and technology. The first session, inaugural session, the conference commenced with the formal inaugural ceremony in the presence of distinguished dignitaries and academic leaders. The chief guest, Madan Dada Bhosle, President of Janata Shikshan Samstha, formally inaugurated the conference. In his inaugural address, he emphasized that interdisciplinary research constitutes a critical framework for achieving sustainable development. He highlighted that the contemporary global challenges, including sustainable energy system, climate change mitigation, healthcare innovation, advanced functional materials, and digital transformation. The session was presided over by Principal Dr. Gurnath Fagre, who underscored the importance of the cultivating the research-oriented mindset amongst the student and faculty. He stressed the need for critical inquiry, analytical thinking, innovation, driving research practices within academic institutions. The second session, the keynote address. The keynote address was delivered by Dr. Sudhir Arbu, scientist, CMET, Pune. His lecture focused on the advanced material research, emerging technology application, and translational aspect of the material science in sustainable development. He elaborated on recent advancement in the material synthesis, characterization technique, and their industrial relevance. The session was chaired by Dr. S.H. Mujawar, Research Director, Karmir Bharao Patil University, Satara, who provided critical observation and summarized the scientific outcome of the session. Third session, expert lecture by the Professor Akio Kimura. The third session featured an expert by the Professor Akio Kimura from Hiroshima University. He delivered an insightful presentation addressing recent developments in the scientific research and interdisciplinary integration in advanced science domain. His deliberation emphasized the international collaboration, innovative methodologies, and future research direction. The session was chaired by Professor Dr. K.Y. Rajpure, who is a scientist from the Shivaji University, who highlighted the academic significance of the lecture and interdisciplinary implications. Fourth session, oral and poster presentation. I am proud to say that the 231 registration registered from the online from various countries like Japan, Australia, South Korea, and I think one more is Israel is there. And also the various countries, various states of the country, and also the different districts of the Maharashtra. The fourth session comprised a technical presentation in the form of oral and poster session across multiple disciplines. In the domain of the physics and chemistry, the total 11 research papers were presented, 6 oral and 5 poster presentation. Contributions were also received from mathematics and statistics, 18, botany and zoology, 18 plus 3, geography, engineering, and allied sciences, 18. The research presentation encompassed a broad spectrum of themes, including renewable energy technology, nanomaterial, and advanced functional materials. Examiners and subject experts from the reputed academic research institution evaluated the oral and poster presentation based on scientific rigor, originality, methodology, data interpretation, and relevance. So the total online and offline registration crossed 450, sir. 450. This is a huge success of this international conference. The participation and outcomes. The conference witnessed participation of more than 450 delegates from the India and abroad through both offline and online modes. The hybrid format significantly enhanced inclusivity and international academic engagement. The conclusion of this all the session, the one-day international conference concluded successfully with positive feedback from dignitaries, speakers, and participants. The event reinforced the institutional commitment of the Kishanveer Mahavidyalaya towards research excellence, innovation, and global academic collaboration. The organizing committee extends sincere gratitude to all dignitaries, keynote speakers, session chairs, faculty members, researchers, evaluators, and student participants from their valuable contribution. The conference marked a significant milestone in fostering interdisciplinary research culture and promoting sustainable academic advancement. Thank you one and all.
Thank you, sir, for wonderful and well-organized summary of the conference. It is my privilege to invite our esteemed chief guest, Honorable Dr. Jayant Chaudhary, Secretary of Janta Shikshan Sanstha WAI, to deliver the valedictory address.
Good evening. We are here for the valedictory function of today's one-day international conference on interdisciplinary approaches in science, engineering, and technology. This concept itself is novel because interdisciplinary, when we talk of interdisciplinary research, it involves so many disciplines coming together. Involved, or some 20-25 years back, the research was restricted to individual subject, of one subject, especially when I was doing my research in 85. there was a difficult time. Nobody was doing research work. Nobody was doing PhD. PhD was not very important even for appointment of professors, even not for appointment of principals also. PhD was not necessary. So my principals were without PhD. Then things changed with the passage of time, and we could have a research center because that was the only after Kolhapur I had a research center in WAI college, our college, and 30-40 students got PhD from our commerce department, MPhil, so many MPhils also. So this research environment itself is a very important aspect of higher education, and it is being ignored. Only teaching, we have to congratulate NAC, sir, for this approach, because previously the colleges were meant to teach, finish the courses, finish the syllabus, conduct exams, declare results, where all are declared as good as pass. So that was the main business of the higher education system. But now the role of higher education has changed. Now every college is supposed to have a research environment in the college, and that is very, very important. And these conferences help in building the research environment in the academic institutions. As Dr. Vategaonkar said, reported that there were 450 participants and so many papers, 150 or more papers. So there is a tremendous response. If we give opportunity to the young talent studying in the colleges and universities, institutions, they can come forward. So this has proved that so many students are going for research, they are involved in research, and they are contributing to so many social, environmental problems, and through research only these problems could be handled and they could be solved. So friends, I can go on adding, because research is a very important area these days. Interdisciplinary concept is a collaborative research. And for collaboration, first thing is we need cooperation amongst the departments. If the physics department and chemistry department, if they are not getting along with each other, how can they have collaborative research, interdisciplinary research? There are some areas, as I listened to the first lecture, that he was citing so many examples of physics and chemistry. They can go together. But going together means both the departments should have cordial relations. Means they should meet very often. At least weekly they should have these collaborative meetings. They could discuss in what area we can do research jointly. And accordingly, you can go ahead. I can give example of my son only, who is a professor in California University. He did his engineering from Pune University, electronics engineering. He went for MS in California University, studied bioinformatics there for MS, got fellowship for PhD from another big university, that is University of Southern California. got PhD, and now he is a professor of radiology. He teaches medical students biomedical imaging. He teaches both engineering students as well as medical students in the University of California, Davis. See the transition. Is a transformation. This can't happen in India. Still, so we have miles to go when we talk of international research. This is not possible in India. A student studying engineering, can he teach medical students in India? No, not possible. And if you see on the website, his department, sir, list of radiology faculty in the university, you will see that Abhijit, my son, name is Abhijit, his name is third, and department is 12 to 15 people, but his name, his PhD, he is not MD, but his name is third, and MD's names are below him. Those who are MDs, that is doctor of medicine, we call MD. Their names are below his name. So research, why his name is in the first three, and doctors in last 10, 15, like if you check on the website. So the reason is the importance of research. They give more and more importance to research, and my son has a lab where he does patient scanning, and he has scanners in his lab, and he has some PhD students, MS students in the lab, working in the lab. So an engineering student doing scanning of the patients in the lab, this is interdisciplinary actually. So this can happen, but we have so many things to do. We have to go ahead in the right direction, and then only things will happen. Now we have interdisciplinary approach in teaching. In colleges we teach different subjects. Even any student, science students can study commerce, you can study arts. So that options is now open. So, but how many students are coming forward to take advantage of that? That is again a problem. So even only restructuring of the syllabus is not only a solution to the problem. So restructuring, okay, but we have to take students in confidence, educate them. The value of internal, if a student can do both business accounting and political science, there are more opportunities for him. Either in political science, he can pursue his masters in politics, or he can join any organization, or in business accounting, he can join a business like. So students should understand the importance of interdisciplinary approach, not only in research, but in actual doing the graduation and post-graduation. So I may go on telling so many things, but already it's late, and so many participants are from our stations. So collaborative research, friends, needs cooperation between the departments, and it could be a challenge if our science departments, all science departments come together and do collaborative research, and that will be a good model for other departments to work and carry forward the idea of collaborative research. So because the conferences, they educate you. It's not only an event, like one event that conference is done and for NAC and this and that. But it should become a process. It should not stop. more and more such an event should happen, and more papers should come forward. And I was just talking to Madan Dada in the morning. He was saying why so many conferences and what will be the outcome, sir? He asked me the question, what would be the outcome of all such conferences? So I told him that this would create research environment in the college. Scholars were there. So each one of the professors, because now it's only teaching is not our job, but research is also equally important. And if we do, at least everyone does a project, one project a year, or at least one project in 2 years, that would add to your knowledge and add to the reputation of the college also. So we have to be very positive as far as research is concerned, because without research, colleges won't sustain. Colleges won't, because only traditional teaching hardly will be, there will be no response in the future for traditional education. As I told you day before yesterday in some report, it is predicted that after 10, 12 years, 80% of the colleges will close. So it is only those colleges who are teaching skills, doing research, will sustain. We have to teach skills, skill development programs we'll have to undertake, and at the same time we have to do research. And that research is not only a library research. Forget about the old concept. In my time, when I was doing PhD, I have to sit in the library, Pune University, this Bombay, because no material for doing research that time. Now you have ample resources at your disposal. No dearth of resources. So the question is, why not? Why not doing the research then? So it is a matter of introspection, that if all things are positive, we should go for research and go ahead, because that will be the outcome of such a conferences create a research environment in the college institution that would be the most admirable and most positive outcome of any research program or any collaborative conference or conference of this sort. So there are so many things to tell you. Interdisciplinary approach, integrating knowledge, methods. I have some few notes here and there, but I don't think I should go on telling you this, because there are so many problems. There are so many diseases, so many problems, social problems are there. Now a debate is going on where the trade agreement with America is good or not. So many papers, in so many papers they are writing this, that. So economists should come forward and enlighten us about the outcome of the trade agreements and all that. So there are social issues, social problems. Take any subject, and there is ample scope for research. It's not only restricted. Science and technology, they are more important because they lead to some research relating to health. Health issues are involved. So science and all this medicine and everything, this research is comparatively more because it is relating to the health of the people. But at the same time, social research is equally important, and in all social sciences, so research carries important place. So today's conference, if we decide, if the professors a researcher decide, they'll come forward, and they show their talent, undertake some research work, and resources can be there, because only money is not the only resource now. You have libraries, good facilities, good infrastructure, all these are resources. So we say ki money is nobody is giving money, nobody was giving money earlier also. But still people are doing research. So that should not be a problem. And this interdisciplinary approach, as you know, combines scientific principles. It helps in designing and building solutions, the technology, applying tools, digital systems and innovations. So if we think of research as a very serious and important field, then we can go ahead. So because I have some prepared few notes, but I am not going through, taking into time constraints. It is because so many have to go long way. So I have already taken your time, but as a chief guest, when I have to speak, because I am waiting for the whole day, because sir told me, because I came for inaugural session, and then I came to know from this invitation that I have to address the valedictory session also. So I have to wait then till this concluding session. Okay, but I like to share my thoughts always. So thank you very much for overwhelming response. All parties, I should thank all participants for such a good, nice response. I should also thank, or rather congratulate the organizing team, because without a good organization, because some of the participants are praising them, so they can't praise unless food is good or the facilities are good. So because they were praising, the arrangements were good, everything was good, and the researchers took advantage, benefit of today's deliberations. So thank you very much, one and all. Thank you.
Thank you so much, sir, for your inspiring experience. Your address has truly encouraged all of us and added great value to this conference. It is my privilege to invite respected Dr. Gurunath Phagre, sir, to deliver a presidential address.
Good evening all. Dignitaries on the dais, Honorable Dr. Chaudhary sir, the chief guest of this function, convener of this conference, Dr. Jhamre sir, Dr. Vategaonkar sir, Vice Principal, Professor Dr. Veer, all the dignitaries and friends. It is now to conclude. So I will conclude within 2 minutes. As rightly pointed out by Honorable Chaudhary sir, interdisciplinary opens the thousands of doors, thousands of opportunities. And one of the participants rightly said that you are to keep yourself knocking the door till it opens, not to go away. We are to knock and knock till the door is opening. So we are to keep ourselves engaged, and then definitely we will get good things. You have to wait for good things also. And by doing continuous efforts, you can find the way you want, the way you wish, and you can come out with the different kind of work, different kind of performance can be shown by you. So we have to collaborate with everyone. As sir said, each department has to keep everyone in touch so as to get the different information that can be useful for the own research, own study. A watertight compartment should not be there. Should not be there. Then and then we can be able to research, and come out with our work that can be better useful for the society. As I said earlier in the morning, the interdisciplinary subject of this conference or the research that is to be made the life simple, easy and happy. So I think all of the delegates might have enjoyed this conference, might have enjoyed the interdisciplinary approaches, subjects, thoughts, deliberations, discussions. And I wish you all that you should take with you this interdisciplinary approach in order to inculcate the best research attitude among you. Thank you.
Thank you so much, sir, for your motivating presidential remarks to break the boundaries, leading us towards a successful conclusion of this international conference. Now we have reached one of the most exciting moments to today's conference, the declaration of the result for the research paper presentation. May I now invite my colleague Rajeshwari Kamte to declare the result. And I would request all the dignitaries to distribute the certificates for the prize holder.
Good evening everyone. In the Faculty of Physics and Chemistry, first prize in oral presentation for Research Scholar category goes to Miss Poonam Kumar.
Please students come fast.
First prize for PG category goes to Mr. Mrugendra Gurav. Next, for the poster presentation in Research Scholar category, in Research Scholar category, first prize goes to Mr. Praveen Bhamre. In the category of PG student, first prize goes to Miss Jasmine Baldar.
Dear participants, give a big hand to our winners. Maybe they get the energy and motivation.
In the Faculty of Statistics, first prize for oral presentation. In the Faculty of Statistics, first prize for oral presentation goes to Miss Preetam Sonmoye. In the Faculty of Mathematics, First prize in faculty category goes to Santosh Amande for oral presentation. Yashwantrao Chavan Institute of Science, Satara. First prize in research scholar category goes to Diksha Barge. First prize for poster presentation in the category of PG student goes to Miss Priyanka Pawar. In the faculty of Zoology, Botany and Microbiology, first prize in oral presentation for PG student category goes to Miss Khushbu Oswal.
Khushbu Oswal from PC College, Baramati.
First prize in the category of research scholar goes to Mr. Pratik Kamble. Mr. Pratik Kamble.
LBS College, Satara. Dr. Pratik Sunil Kamble from LBS College, Satara.
Next, first prize in oral presentation in the category of faculty goes to Mr. C.B. Zamdade. Sorry, Mrs. C.B. Zamdade.
Give a big hand to encourage our winners. Once again, give a big hand.
First prize for poster presentation in the category of UG student goes to Mr. Aditya Nagre. In the faculty of Geography, first prize for oral presentation goes to Ms. Sakshi Dere.
Sakshi Dere is the student of our Kishanir Mahavidyalaya WAI from the BCA department. BCA third year student.
Thank you everyone for inviting me here. Thank you.
Once again, congratulations to all the winners and participants. Your research work is truly inspiring and we wish you great success ahead. May I now invite Dr. R.H. Vadu, sir, to express a sincere gratitude to all those who contributed for this international conference.
Distinguished dignitaries on the dais of the dais, respected speakers, faculty members, dear participants, students, good evening to all. Today has been a day of learning, sharing and meaningful interaction. This conference brought bright minds from different fields on one common platform, from the inaugural session to keynote address, invited talk, technical presentation and discussions. Every session added new knowledge and fresh ideas. I sincerely thank Honorable Madan Dada Bhosle, President of Jata Shikshan Sanstha WAI, for kindly accepting our invitation as a chief guest for inaugural session and for encouraging us with his presence and guidance. I express my heartfelt gratitude to our keynote speaker, Dr. Sudhir Arbuj, and invited speaker, Professor Akio Kimura, for sharing their valuable insights in such an inspiring and understandable way. I also thankful for the session chairs, Dr. S.H. Mujawar and Professor Dr. K.Y. Rajpure, for smoothly conducting the sessions and guiding the discussions. I am also thankful to all technical session chairs. I am especially grateful to Honorable Dr. Jayavant Rao Chaudhary for gracing this valedictory function as the chief guest and for motivating us with his thoughtful words. My sincere thanks to all office bearers of Janata Shikshan Sanstha for their constant support and encouragement. I express my deep appreciation to our respected principal, Dr. Gurunath Phagare, whose vision, guidance and continuous support made this international conference possible and successful. A big thank you to all researchers, presenters and participants. Your active involvement, thoughtful questions and enthusiasm made this conference lively and meaningful. Behind every successful event, there is a hard-working team. I truly appreciate the efforts of organizing committee, faculty members, non-teaching staff and our dedicated students who worked tirelessly to make this event smooth and memorable. Lastly, I thank each one of you for your valuable time and presence. Your participation made this conference truly special. As we conclude, let us carry forward the ideas, connections and inspirations we gained today into our future research and work. With heartful gratitude, I conclude my vote of thanks. Thank you all.
Thank you, sir. All the participants are requested to submit your feedback form on the registration table and collect your certificate from this table only.